Yes, sir. Good afternoon, sir. Welcome back.
Good afternoon, sir.
Yes, good afternoon,
Okay.
everyone. Welcome back.
Good afternoon, friends. I think some people has to come, right, sir? I
Yes,
think
sir.
it will take some
Yes,
time.
they will
Okay.
join, sir.
Okay. Anyway,
Making you as a host, sir. You can take
yes,
the
sir.
control. Yeah.
Yes. Yes, sir. Sir, can you able to see screen, sir?
Yes, sir. Yes, sir. Absolutely fine, sir.
Okay, sir. Right.
Yes.
Right, sir. Okay. I'll start. I'll wait for some time. After that, I'll start. Okay.
Sure, sir.
Okay, sir.
Sure.
Right. Good afternoon, Muthu Krishnan. Hello. Nirmala.
Good afternoon, sir.
Yeah. Is it audible to you, everybody?
Yes, sir.
Okay. Vidyavani, Mohan Priya, 6 people only came. We'll wait for some time. Let them come, your friends. Okay. In the meanwhile, do you have any doubts, ma, regarding morning discussion? Please let me know.
No, sir.
Okay. 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 Because types of magnetic coupling topic. No, it was somewhat. It will be somewhat theory oriented. I should have some concentration, but it is very important for understanding a transformers chapter. Okay. So it should be very for deciding direction of flux in right hand thumb rule. That will be very clearly understood after explaining this topic. Okay, right. Just wait for some time. Shubha, she's coming. Right. Okay. Next. Hmm. Okay. Okay. When you are having exam at TNAB or TRB?
So it will be by February like that, sir.
February,
They
yeah.
did not announce the date, sir.
But application submission completed, huh?
Yes, sir. Already submitted, sir.
Okay. Which one? TNAB as well as the TRB also, right?
No, sir. I am applying only for TNEB, sir. And also
TRB.
I applied for
No, generally
dates.
TRB, TNEB applications completed up. I mean, submission of application date completed up.
I don't know about TRB, sir, but TNEB application closed, sir.
Closed. Okay, okay. Right, right. Yogeshwaran. Come, come, come. Muthukrishnan. Muthukrishnan.
Sir,
What about morning session class? Is it understood to you? I mean, do you have any doubts in that?
no, sir.
No. Okay. Very good. Yogeshwaran.
Yes, sir.
Had your lunch?
Yes, sir.
Okay. Right, right. Yeah. Nine participants, right? I think morning 12 people was there. Let us see. Waiting for the room, Rahul. Okay. Bonesh. Rahul, Bonesh. Can you listen my voice? Is it audible? Bonesh? Hello? Rahul, is it audible? Rahul, please respond. Hello. Is it audible, Amma? Remaining people, Mohan Priya, is it audible, Amma?
Yes, sir.
Yes, sir. Audible, sir.
Yogeshwaran, is
Audible,
it
sir.
Yes,
audible?
sir. Yes, sir.
Can I start?
Yes, sir.
Yes, sir.
Okay, thank you. See, yeah. See, morning I told in transformer windings are electrical isolated, but they are magnetic coupled, right? Okay. So magnetic coupled means what? Example, if you see a primary winding, secondary winding. So after giving a time varied voltage source to the primary winding of transformer, it will take some current. So flux will be produced. Say that flux links with the primary winding as well as it is coming to secondary winding through transformer core. It links with secondary winding also. That means same flux is linked with both windings. No, so I can say that the two windings are magnetically coupled through transformer core. Okay. See, in this magnetic coupling, generally we are having two types here: positive type of coupling and a negative type of coupling. Okay, is it clear, everybody? Positive type of coupling and a negative type of coupling. Gopinath, yes, let me admit him. Okay. Types of magnetic coupling, we are having two types: positive type of coupling and a negative type of coupling. Okay, guys. Can you able to see a screen on the on your mobile? Figure
Yes.
number 1, figure number 2, figure number 3, figure number 4, types of magnetic coupling topic.
Yes,
Everybody?
sir.
All right,
Yes.
very good, very good. Okay. See, guys, before explaining, let me ask one simple basic question. After that, I'll start. Okay. So, suppose if I take a source, if I take a source like this, okay. Here, let me take this terminal as phase. Let me take this terminal as phase, and let me take this one as a neutral one. Okay. So for the understanding point of view, generally AC means phase and neutral I had to show. So for the understanding point of view, I'll do one thing. Phase can be taken as a plus here, and neutral can be taken as a minus for the understanding point of view. Okay. Tell me, guys. Generally, source means where current is entering, at which terminal current is entering, and at which terminal current is leaving here. Please try to tell me.
Positive terminal current is entering and negative
Current
terminal
No,
it
no,
is
no, no.
leaving.
Be careful, be careful. I'm asking about
Current leaves
source.
the positive terminal.
Very good, very good. At a positive terminal, current leaves, right? Okay. Whereas it enters at a negative. This is a source, right? Generally.
Yes, sir.
Is it Rahul? Yes. Okay, clear. Yeah. Current always leaves from a positive terminal. It enters at a negative terminal. Like I said, this much small basic you should have for understanding the topic. Okay. Now tell me, tell me. So suppose if it is neutral and it is a phase, I had taken this example figure number 1. Aarti is ready to enter the room, waiting room. Yes. Let me admit her. Okay. Okay, guys. Suppose in this figure, if you take this one as a source, I'll explain connections, all those things afterwards. First of all, let me focus only on source. As I told you, current enters at a neutral terminal. Sorry, enters neutral terminal. It leaves from phase terminal. That means here, this is the direction of current. Okay. And it is coming, it is entering neutral means ultimately it will be like this. No. Okay. Like that, let me show for all figures. After that, I'll explain. So it is entering at neutral, is leaving from phase. It is like this here. Arrow mark is like this here. Similarly, let me take a third figure also. At neutral it is entering. Phase which is leaving. It is like this here, and like this at this end. Okay. And once again, neutral it is entering. Phase which is leaving. So it is like this. Okay, guys. Is there any doubt up to this portion? A small thing only explained. Please try to respond, Amma. Everybody, is it clear?
Yes, sir.
Yes, sir.
Everybody, please, ma,
Yes,
Aarti,
sir.
Yogeshwar, everybody.
Yes, sir.
Please.
Yes,
Very,
sir.
very good.
Sir,
And please, ma.
sir, explain again, sir.
Okay, I'll explain one second. Please wait. See, I'm saying simple thing. Suppose if you take a source, like this, you already know that if you take a source, in a source always current enters at a neutral terminal, or I can say minus terminal. It leaves from a phase terminal, or I can say it leaves from a positive terminal. This much basics already everybody knows. Okay. So you might have seen circuit theory everywhere you can see. Okay. I mean, if you take a source, I'm discussing about source. If you take this one as a source, I'm saying current enters at a neutral terminal, it leaves from a phase terminal. So simply, I'm just taking here everywhere, wherever source is there in figure number 1, figure number 2, figure number 3, figure number 4. This only I just indicate here. So I just shown such that current is entering at neutral terminal, current is leaving from a phase terminal. So this arrow mark I just showed, this arrow mark I just continued. Okay, like that in this source, in this source, in this source, same thing I just indicated. That's it. I did not start subject till now. Okay, is it clear up to this, everybody? Everybody, ma?
Yes, sir.
Yes,
Okay.
sir.
Now let me ask question. Okay, so guys, first of all, you should be very familiar with the sense of winding. First of all, what is the sense of winding? So in advance, I'm saying, guys, since it is a somewhat theory oriented topic, since already we had taken lunch, no doubt you'll be getting sleep. Please don't sleep. What I'm saying. Okay, are you getting what I'm saying? That too, it's a festival. I think you had taken too much food. Is it clear? Rahul,
Yes.
had you taken more or less? Huh? What? Tell me, yaar. Have you taken more or less? I'm saying.
Yes, sir, sufficient only.
That's what I'm. Don't take too much food because while taking class, definitely without knowing ourselves, we'll get sleep. That's the problem. Okay. So please be active in the class. Everybody, Nirmala, Yogeshwaran.
Yes, sir.
Okay, ma. Okay. So here my question is very simple question I'm asking. So first of all, please tell me here in this, I'm just explaining the types of magnetic coupling. For that, I had taken a core like this. Okay, it's a core. It's let me take a simple core, or I can say it's a magnetic material. It's simply a magnetic material, and that I just wounded two windings. Okay, so blue color winding and red color winding. So see here, blue color, red color winding, they are connected. It doesn't mean that it's a transformer, right? In transformer, you know, it's windings are not electrically connected. That everybody knows that. For explaining types of magnetic coupling, I had simply taken this one. That's it. Okay. So please, it's a blue color winding. It's a green color winding. Once again, here also blue color, green color, sorry, blue color and red color winding. Blue color, red color, blue color, red color. And in this figure number 3, I had taken once again yellow color, green color, yellow color, green color. Now I'm asking a simple question. So please try to focus on figure number 1, guys. Figure number 1, everybody. Are you able to see figure number 1?
Yes, sir.
Yes, sir.
So tell me how you are deciding here front end and back end. That is my simple question I'm asking. How you are deciding front end and back end. I need an answer from you guys so that subject will become very easy for you if you interact. Tell me how you are deciding front end and back end.
Front end is
Winding
connected
is
to supply.
No,
Supply
it's not.
voltage.
It's not like that. It's not decided by supply. Simply, it's a way how you are wounding. It's a simply way how you are winding. Example, you do one thing. Everybody, you have to listen, Amma. Please take this white color core, whatever you are able to see. Just try to hold this with your left hand. Let us assume that you are holding this core with your left hand. Are you able to hold this left hand? So simply, you are holding here. Okay, you are holding here. Just try to hold this core with your left hand thumb and forefinger. Let me use whatever fingers. Let me hold that core by using left hand. Okay, and by using right hand, you are wounding this winding on the core. In the first case, guys, observe clearly. I'm just wounding. Your winding is going from front side of the core. It is leaving from the back side of the core. Simple, might say just a wounding only. Just you know, yeah, what? How can I say? Are you able to understand what I'm saying? Suppose simply just
Yes,
just simply take a core and just try to wound a winding on that core. That's it. Suppose if a winding is going from front side of the core, that can be taken as front end. Okay, so it is going from front side, it is leaving from back side. It is going from front side, it is leaving from back side. Just simply, I'm just wounding like this. Okay, just like a thread. You know, I'm just wounding a thread like that. You are wounding a winding at the transformer core. That's it simply. Okay. So I just wounded. I mean, this is nothing but winding is going from front side of the core and from back side is leaving. Once again, it is entering at front side of the core. I just wounded like this. Once again, from front side, it is going back side, going front side, back side, okay, front side, back side, front side, back side. Back side you cannot able to see. Is it clear, everybody? And if you come to coil B, if you come to coil B also, your winding is going from front side of the core. This is whatever you are able to see this winding, this front end only, this one, okay? You cannot see back end in this figure, okay? So it is leaving from back side, it is entering at front side, leaving at back side, entering at front side like this. So going on and so on. your winding is leaving from backside of from back end of the core. So like that, simply front end, back end is simply is the way how you are winding. Suppose if winding is going from front side of the core, that is nothing but front end. If winding is coming from back side of the core, that is nothing but back end. Here also winding is going from front side of the core, is the front end. It is coming from back side of the core, is the back end. Are you able to understand what I'm saying, guys? Is there any doubt up to now? Please, everybody, let me know. Everybody.
Yes, sir. Understand, sir.
Understood, ma?
Yes,
Everybody? Yogeshwaran, everybody?
Yes, sir.
Okay. Tell me, now let me take figure number 2, guys. Figure number 2. Figure number 2 also, if you observe, sense of winding is same just like figure number 1. Because in coil A, coil B, if you see here, coil A, this end is front end. Here also I have taken front end. And this end is back end. Here also is nothing but back end. Here is front end. Here also I have taken front end. Here also back end. Here also I have taken back end. Is there any change in sense of winding, guys? Don't, I mean, forget about winding connections. I mean, in this case, back end is connected to front end, and here source is connected between the front end of your coil A and the back end of your coil B. That is different case. Whereas in this case, back end is connected to back end, source is connected between the front end of coil A and the front end of coil B. That is a different case. I'm asking simply, is there any change in sense of winding? I'm asking from figure number 1 and figure number 2. Respond, please.
No, sir.
Everybody, I need answer from everybody. See, especially this topic, I need interaction from everybody. Mohan Priya, Yogeshwaran.
No, sir. There is no change of.
Okay, Vimal.
No, sir.
Huh?
No.
Okay. What about Aarti?
Change, no changes, sir.
Are you
change in
understand
winding.
what I'm saying? Front and back and all those things. Okay.
Yeah,
Now,
okay, sir.
what about
Okay.
Bhuvanage?
Understood, sir.
Bhuvanage,
Understood, sir.
Muthikrishnan, Nirmala.
Yes, sir. Understood, sir.
Okay, ma. Okay, very good. Shubha,
Yes, sir.
Vidyavani.
Understand, sir.
Very good, ma. So now what I'm saying is, guys, there is no change in the sense of winding from figure number 1 to figure number 2. That much is enough for at present. Okay. Now what I'm saying is, so I'm just going to explain. One point. What is that point? Though sense of winding is same. Example, if you take figure number 1, figure number 2, though sense of winding is same, I am just going to change type of coupling. Suppose figure number 1, if I get positive type of coupling, figure number 2, I'll get negative type of coupling. That means what? For the same sense of winding also, type of coupling can be changed. This I'm just going to explain. Is it clear, guys? This
Yes,
point
sir.
I'm just going to explain. Is it clear? Okay. Now, everybody on the board. So please try to see in this coil A of your figure number A, where current is entering. It is front end or back end? Please, ma, respond, ma. Where
Front
current
end,
is entering,
sir.
I'm asking. Front end or back end?
Front end.
Front end.
Now, please see, you have to tell, and I'll simply mark it. It is entering at a front end. Very good. Next. It is going. Where it is leaving, ma?
Back end.
Back end. Can you able to see back end, guys, here?
No,
Yes,
sir.
sir.
No. Where you are? Can you see here? You cannot see back end, right? Rahul, somebody told. No problem. It's not issue. Tell me. It is entering at front end, ma. It is back side is leaving. No, at that back side of your coil portion is behind this transformer core that you cannot see, right? Everybody,
Yes, sir.
is it clear? Everybody?
Yes, sir.
Yes,
Okay.
sir.
So please, it is entering at front end, leaving at back end. One side is entering at front end, no? Yes. This is arrow mark. Now, once it is leaving at a back end, it is entering at a front end. Next, ma, leaving at back end, entering at front end, leaving at back end, entering at front end, leaving at back end, entering at front end, leaving at back end. Yes, it is back end. Here it is leaving. Is there any doubt in this arrow marks till now? Please.
No, sir.
Everybody.
No, sir.
So tell me this arrow marks, whatever I just shown here, this portion, upward arrow marks I just showed. Tell me this nothing but direction of current, no?
Yes,
Yes,
sir.
sir.
Direction of current only. If you observe, if you remember, if you imagine at the back side, arrow marks will be downwards, upwards.
Downwards.
Downwards.
Very good, ma. Very good. That much is enough. Okay. Yeah. See, electrical machines are very easy. Yeah. Don't think it is a very difficult subject. If you understand clearly, it is very easy. Okay. Now, current is coming and where it is entering at coil B, front end, back end.
Front end.
It is entering front end. Once again, same logic. It is entering at front end. So it is leaving at back side. Once it is entering at front end, leaving at back side, entering at front end, leaving at back side, entering at front end, leaving backside, entering front end, leaving backside, entering front end. It is leaving from backside. Yes, this is the arrow mark. Is it enough? Is it understood, everybody? This arrow
Yes,
marks?
sir.
Now tell me, I'm asking a simple question. Everybody, please try to be ready for answering this question. Okay, guys? In figure number 1, everybody I'm asking, okay? Otherwise, I'll tell names. Those people you have to tell, okay? Don't scold me, okay? Some people are scolding. I think. Is it clear? Hello?
Yes, sir.
Okay, sir.
Yes, sir.
Yes, you are scolding me, right?
No, sir.
No, sir.
I am saying that you are scolding me. For that also you are saying yes, sir. Right. See,
No, sir.
so every time he is asking question, that like that you people will be feeling and you are scolding me. No problem. If you scold us, nothing will happen to me. So what I am asking is, in coil A, direction of current is upwards, no guys, upwards. Okay. Now I'm asking, tell me what is the flux direction due to current flowing in coil A. Use right hand thumb rule and tell me, is it right to left or left to right? Simple question I'm asking.
Right to left.
Think clearly and tell me, everybody.
Right to left.
Right to left, huh?
Right to left, sir.
Any different answers? Everybody, please, ma. I'll ask name, one by one. Okay. I'm asking, first of all, let me ask the question. After that, I'll ask answer from you guys. Please try to see figure number 1 and coil A and coil B. First of all, try to focus on coil A. In coil A, direction of current from front side is upwards, from back side is downwards, that you cannot see. In coil B, direction of current from front side is upwards, from back side is downwards, which you cannot see here. Now I'm asking simple question. In coil A, what might be the direction of flux? Is it from right to left or left to right? Some people told right to left. So is there any change in answer? Mohan Priya?
Sir, left to right, sir.
Left to right. Okay. Next, any different answers? Vimal?
Clockwise. Left to right.
Right to left, sir.
Vimal? Yogeshwaran?
Right to
Right to left, sir.
Aarti?
Right to left, sir.
Okay, ma. Next, Gopinath? Gopinath?
Right to left. Yes, sir.
Very good. Harish, please.
Right to left, sir.
Right to left, huh? Okay, let me
Yes,
just wait for some time. Nirmala?
Right to left, sir.
Rahul? Rahul?
Sir, right to left, sir.
Subha?
Right to left, sir.
Vidyavani? Vidyavani, ma. Vidyavani? Vidyavani, is it audible to you, ma? Okay, no problem. Let us see. So most of the people told that right to left, right? Right to left. I think one person only told left, right? No, let me conclude. Let me decide. Okay. So please tell me, I have to use figure number 1 or figure. See, try to see these images, ma. Can you able to see images on the right side of your screen, everybody? Can you able to see these images, everybody? This one.
Yes,
Can you
sir.
able to see this? Okay,
Yes,
ma.
sir. Yes, sir.
Everybody.
Yes, sir.
So please try to see this image. If you hold this white color core in, you have to hold your core like a figure, like image number 1 or like image number 2. I'm asking
Image
this,
number
in
one.
this
Image
figure,
number
figure
one,
number
sir.
1, in this figure number 1. So regarding coil A we are discussing. Tell me at that time how you have to hold your core.
Image number 1, sir.
Image number 1, sir.
Image number 1.
Very good, ma. Why means try to see this arrow mark. Are you able to see this arrow mark?
Yes, sir.
Yes.
Okay, this is white, this is
Yes,
black
sir.
color arrow mark. Okay, it is upwards, right? This indicates direction of this yellow color, whatever I just indicated, yellow color arrow marks. These arrow marks are the direction of current from front side. Okay, nothing but direction of current from front. This one. Okay, you have to hold your wrapped fingers in this manner, and your thumb indicates direction of flux, which is from right to left or left to right, Amma? Please tell me.
Right.
Right.
Right to
Right
left.
Right to left.
Very good, very good. Right to left. Therefore, this is nothing but right to left, nothing but flux due to coil A. Very good. Now tell me in coil B, guys, coil B, where current is entering front end. It's a very simple common sense, guys. Whenever current is entering at front end, no, you please use the image number 1, Amma. That is enough. Whenever coil is entering at the back end, you have to use image number 2. That's it. Now see in coil B, where current is entering, ma, front end or back end?
Front end.
Front end.
Front end. That means you have to use the figure number, image number 1, image number 2, Amma.
Image number 1.
1, sir.
Image number 1, very good. So image number 1, see direction of current is like this, no, blue color, sorry, black color. Here also
Yes,
this yellow color, nothing but direction of current only. Okay, we cannot see direction of current which is leaving from back end, that we cannot see. Okay, so if you hold your core like image number 1, so tell me once again, what is the flux due to coil B? Direction of flux due to coil B, I'm asking.
Right to left.
Right to left, sir. Same as.
Same, very good, Mas. Very good. Okay. Right to left. So right to left. This is what I can say, pi B. So ultimately, one thing you can say, so tell me here in this figure number 1, your pi B is aiding pi A, or it is opposing pi A?
Aiding, sir.
Aiding. So if two flux are aiding with each other, so I can call the type of coupling as a positive type of coupling simply. Okay. So let me write that point here. Yes, here I can say pi B aiding with pi B aiding with pi A. Aiding with the pi A. So which type of coupling? Therefore, positive type of coupling. So for positive type of coupling, guys, between this coil A and coil B, I said it is magnetic coupled. No, yeah, you'll be having some mutual inductance. M means what I can say, mutual inductance. So this M value will be positive for positive type of coupling. Is it clear up to this? M value equal to positive for positive type of coupling. Okay, now tell me ultimately figure number 1. Figure number 1, you are getting positive type of coupling or negative type of coupling?
Positive type of.
Positive,
Type of
sir.
coupling.
Positive
Okay.
type.
Now, yeah, is it clear everybody? Figure number 1. Can I go for figure number 2? Everybody, please.
Yes, sir.
Yes.
Yes,
Now
sir.
tell me, tell me figure number 2, guys. Figure number 2. It is just like figure number 2 coil A is just like a figure number 1 coil A only, because here front end back end same, no. So, but try to observe, guys, clearly in figure number 1, back end is connected to front end. Back end of your coil A is connected to front end of coil B, and the source is connected between the front end of coil A and back end of coil B. Okay, whereas in figure number 2, guys, back end of coil A is connected to back end of coil B. Source is connected between the front end of coil A and front end of coil B. Is it clear? Can you able to see that one?
Yes, sir.
Everybody?
Yes,
Yes,
sir.
sir.
Okay, ma. Now tell me here in figure number 2 in coil A, how current is entering, ma? It is entering at the front end, no, like this.
Yes, sir.
Okay. It is leaving from back side. Huh?
Right to left.
Okay, very good. Let me first of all show direction of current. Okay, upwards here. It is leaving it from back side, but please be careful. Current is going like this. It is entering at where? Back end or front end of coil B?
Back end. Back end.
So back end means, see, try to understand, try to remember. You have holding your core and you are wounding winding such that you are starting. Your winding is going from backside of the core first of all. Now from backside is coming to front side like this. Backside, front side. You are wounding like this. Okay. So current is entering at back end, ma. So that we cannot see the direction. Upward direction will be there, but we cannot see that direction because it is a backside. No, it is entering and leaving from front end. That means it here arrow mark will be downwards or upwards.
Downward.
Downwards.
It is upwards, but that you cannot see. But leaving from front end means yes, downwards. Very good, very good. Once again, entering at the back end, that we cannot see, leaving from front end. Yes, entering at back end, leaving from front end. Entering at back end, leaving from front end. Entering at back end, leaving from front end. Entering from at back end, leaving from front end. Yes, it is leaving like this. Okay, guys. Now, please tell me in figure number 2, coil A, what might be the direction of flux? I have to use image number 1 or image number 2? Please think.
Image number
For
1.
Image number
image
one.
number 1, sir.
Very good, ma. Very good. Because see this arrow mark. Okay, this arrow mark. Please try to see. Let me use a laser pointer. You can understand. Yes, this arrow mark upwards. No.
Yes,
And
sir.
here in the coil A, if you see direction of current upwards, no. So you have to use. You have to show like this. Okay. So now, what about coil B? Coil B. If you want me to use the image, which image I have to use?
Second
Coil-
image, sir.
Second image.
Second, very good, ma. Because see, you have to hold core like this in this manner. See, the current is coming downwards, right? See, current downwards. Okay. So please tell me ultimately in the
Opposing
coil
flux,
A,
sir.
direction of flux will be from
Left to right.
I'm asking coil A, coil A, coil A.
Right to left, sir.
Right to left only, pi A. Okay. Whereas in coil B, ma,
Left to right.
hold like this. So image number 2, hold like this. Thumb indicates direction of flux, no?
Yes,
So
sir.
try to, let me show this laser pointer. This thumb indicates direction of flux, which is from left to right. Okay. So now ultimately, yes, direction of flux will be from left to right in like this, in this manner. What I can say, pi b. Okay. Right. Now tell me here, pi b and pi a, they're aiding or opposing?
Opposing.
Very good, ma. Pi b opposes pi a. So whenever pi b opposes pi a, if two flux are opposing, tell me
Negative type.
type of flux, ma?
Negative type of coupling.
Type of coupling. Negative type of coupling. Where mutual inductance M will be how much? I mean, M will be negative or positive? Negative. Okay, guys. So if you observe clearly in these two figures, figure number 1, figure number 2, first of all, I explained figure number 1, no? So let me take this one as a reference first. Okay. So tell me, guys, figure number 1, figure number 2, sense of winding same or different? Figure number 1 and 2, sense of winding same or different? Same, different. Respond, please.
Same, sir.
Same, because the
sir.
front end, back end, front end, back end, same. No, sense of winding same. That's why I clearly wrote here. I just made one flower bracket. Flower bracket indicates I wrote here same sense of winding. Means what? These two figures having same sense of winding, and these two figures having same sense of winding. There's a meaning for this indication. Okay, guys. Now, though sense of winding is same, if you observe clearly, figure number 1 we are getting positive type of coupling, whereas figure number 2 we are getting a negative type of coupling. How it's happening? Observe clearly. If you see coil A current direction upwards here coil A direction ma upwards. Coil B current direction upwards ma. Here coil B current direction ma. Tell me.
Downwards.
Downwards. That means if you change direction of current in one coil, let me conclude. So though sense of winding same, if you change direction of current in one coil, so what will happen to type of coupling? Will change or will not change? I'm expecting answer from you guys. Hello.
Will change, sir. Will change,
Everybody,
sir.
why you kept so? Is there any problem in understanding?
No, sir. Got it, sir.
Nirmala, Rahul, Vignesh, Shubha,
Got it, sir.
Vidyavani. Understood,
Got
ma?
it, sir.
Understood, sir.
Very good, ma. So what I'm saying is, yes, right. Let me explain once again, guys. What I'm saying is very simple thing I'm saying. So sense of winding same here. I think those people who attended a class slowly. I think lately some people came. So please try to watch that. Try to. So I said that's what I'm saying. Please try to be to the class regularly. In time, you should be there. Okay. This one is front end. This one also front end. Back end. Back end. Front end. Front end. Back end. Back end. So sense of winding is same. Though sense of winding is same, type of coupling is changed here. If you see in this figure, I taken figure number 1 as reference, where we are getting positive type of coupling. So this positive type of coupling is changed to negative type of coupling. How it's happening means by changing direction of current. If you see coil A current direction, it's upwards. Here also upwards. If you see coil B current direction upwards, but coil B of figure number 2, if you observe, current direction is downwards. Therefore, so ultimately, I can give one statement. What is that statement? For the same sense of winding, type of coupling can be changed. How here? Tell me. For the same sense of winding, how can you change the type of coupling? Everybody? Anybody answer? For the same sense of winding, how can you change type of coupling? Please. Rahul, Vigneshwaran.
By connecting the back end with
No,
the
no,
back
don't,
end.
don't see about connections, sir. So
Yes.
tell me regarding current point of view. In terms of current point of view, tell me.
The flux is opposite direction.
Okay. Positive means the two flux are aiding. Negative means they're opposite. That is okay. I'm asking, whenever sense of winding is same, then also type of coupling can be changed. How it is possible? Means simply you have to tell answer by changing direction of current. That's it.
Yes, sir.
See, coil B current direction upwards, no? Whereas coil B direction here in figure number 2, it's downwards, no?
Yes,
Are you
sir.
able to see, ma?
Yes, sir.
Don't see when figure number coil number A of your figure number 1, coil number A of your figure number 2, that is okay, same. I'm asking about coil B. Please try to focus on coil B. Coil B current direction is upwards in figure number 1, whereas coil B current direction is downwards in figure number 2. That means if direction of current is changed in one coil, though sense of winding is same, type of coupling can be changed. That's it. Is it clear, guys? So that statement only I had given clearly here. Please try to see in the next slide. I wrote this point. Please try to see. Let me study this point. For the same sense of winding. So for explaining this note, you can use figure number 1 and figure number 2 which we explained now, or figure number 3 and figure number 4 you can use. Any two, not 4. I mean 4 figures are not necessary. You can use figure number 1, figure number 2 where sense of finding is same, or you can use figure number 3 and figure number 4 where once again sense of finding is same. Are you getting what I'm saying? Use 1 and 2 or 3 and 4. I explained 1 and 2, and you have to tell from your side figure number 3 and figure number 4. So I'll come to that. Before that, let me study the statement. For the same sense of finding, yes, type of coupling can be changed. How here? Type of coupling can be changed by,
Changing
please.
the direction of current.
Direction of current.
Changing direction of current. That means indirectly changing direction of current. In our example, coil B. That's it, no? In coil B, figure number 1, if you observe, it's upwards. Figure number 2, it is downwards, no? By changing direction of current means by changing direction of current in one coil. There is a meaning. Is it clear, guys? So for explaining this statement, for justifying this statement, I used figure number 1 and figure number 2. Now it's your turn. You use figure number 3 and figure number 4, where once again sense of finding is same, and please justify this statement. I mean, this statement to be, this statement to be, this statement has to be proved by you by using figure number 3 and figure number 4. Let me show that slide, and it's your turn. You have to tell me, guys. Are you getting what I'm saying? Use figure number 3 and figure number 4, and let me explain. Please tell from your side, guys. Are you ready, everybody?
Yes, sir.
Now tell
Yes,
me,
sir.
in this figure number 3 and coil A, where current is entering, front end or back end?
Front
Front
end.
Front end, sir.
Leaving at back end. Okay, entering at front end, leaving at back end, 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 entering at front end, leaving at back end. Okay, so once again, where it is entering?
Back end.
Back end, sir.
Back end, it is entering back. I cannot show that arrow mark. It is leaving at, it is entering at back end, whereas leaving from
Front end.
very good. Entering at back end, leaving from
Front end.
entering from back end, leaving from front end, entering at back end, leaving from front end, entering at back end, leaving from front end, entering at back end, leaving from front end, like this. This will be the direction of current path. Okay. Okay, guys. Now, if you observe clearly in figure number 3, it is a front end, no? This one. Let me show you that sense of finding is same. So please try to see this one. Front end, this one, coil number A. What about figure number 4? This end, front end only, no? Back end, back end, back end, back end, front end, front end. So sense of finding is same or different? If you compare figure number 3 and figure number 4.
Different.
Sorry? I'm asking same or
sir.
different?
Same,
Same,
sir.
sir.
Same, no. I'm not asking 1 and 3. I'm not asking 2 and 4. I'm asking 3 and 4. So here front end, back end, back end, back end, back end, front end, front end. Sense of it is same or different? Same.
Yes.
Same. If you already explained the figure number 1 and 2, if you observe front end, back end, back end. Here front end, back end, back end. Here sense of it is same or different? Figure number 1 and 2, same or different?
Same,
Same,
sir.
sir.
Same,
Figure
sir.
number 3 and 4,
Same,
same or
sir.
different? So I explained figure number 1. I use figure number 1 and 2. I justified the statement. Now you have to use figure number 3 and 4, and please complete this topic. Okay. So please,
Sir.
yeah, please, Sharma.
Figure
Fluxes
number
are
3,
opposing, sir.
negative type of coupling, sir.
Very good, ma. Very good. See, let us see. So figure number 3, current is entering at front end. No, I have to use image number 1, image number 2, ama.
Image number 1.
sir.
2, 2.
1, ma. 1, please. 1. No, don't say
Yeah,
2.
yeah.
Okay. 1, no.
Okay, okay.
See
Okay.
this arrow mark. Try to see this black color. Yes, this is nothing but arrow marks indicates is a yellow color flux lines only. Sorry, yellow color current direction only. Okay. Now, so you have to hold your core in this manner at a coil A. So your thumb means from right to left. So it will be right to left, pi A. Very good. Now, guys, where the current is entering at coil B? Back end or front end?
Back end.
Back end.
Back end means you have to use image 1 or image 2.
Image 2.
Image to
Image two.
try to see this arrow mark. Okay. And here also try to see this arrow mark. Same, no? You have to hold core in this manner, like for image number 2, and thumb will be from left to right. So tell me flux direction, left to right. Means pi B will be in this manner. Yes, ma? Okay.
Yes,
They're
sir.
opposing or they're reading Amaida in this case. Tell me, in
Opposing.
this case, opposing.
Opposing, sir.
Yeah, pi B opposes pi A. So therefore, which type of coupling?
Negative type
Negative
of
type
coupling.
coupling.
Very good. Negative type of coupling. Negative type of coupling. Okay. So where M will be negative.
Negative.
Okay. So let me ask one simple question. Whenever I explained figure number 1 and 2, I think I had taken a reference as figure number 1. No. Okay. Nothing but a positive is reference for us. From positive to negative I got. Okay. Now in this figure number 3 and figure number 4, can I take figure number 3 as reference now? Yes or no? I'm
Yes,
using
sir.
figure number 3 and figure number 4. First, I'm explaining figure number 3. Let me take it as reference. That means which one is reference for us? Negative or positive?
Negative.
Negative. So negative should be changed to
Positive.
Positive.
positive. That I'm just going to show in figure number 4. That's it. Okay. Now please tell me in a figure number 4, guys, is it direction of cut is correct here? Entering here at front end, leaving from back end, entering at front end, leaving from back end, entering at front end, entering at front end, entering at front end, leaving at back end. Yes, yes, yes. Now where current is entering in coil B also?
Front end.
Front end only. Entering, leaving at back end that you cannot see, entering at front end, leaving at back end, 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 entering at front end, leaving at back end. Very good. This one. Okay, guys. Now tell me, use for explaining the direction of or knowing the direction of flux due to coil A, you have to use image number 1 or image number 2? 1 or 2?
One.
One.
Ma, tell me, ma, 1 or?
One.
So yes, see this arrow mark upwards, no? Here also upwards. If you show like that, thumb will be from right to left or left to right?
Right to left.
Very good, ma. So this is what I can say, pi A. Now what about in the coil B? I have to use figure number 1 or figure number 2?
Figure number 1.
One, sir.
Number 1.
Tell me figure number 1 or figure number 2?
One,
1,
sir.
sir.
One.
Very
One,
good,
sir.
very good, very good, very good. So once again, 1 only, okay? Because it's entering at front end now, ma. Okay. So 1. So flux will be right to left or left to right?
Right to left.
Right to
Right
left.
to left, sir.
Very good, ma. Okay, right to left. Pi B. So there are aiding or opposing?
Aiding.
Aiding.
Aiding,
So
sir.
pi B aiding with you can say pi A. Therefore, which type of coupling?
Positive type.
Positive type.
Positive type of coupling. Positive type of coupling. Okay. So where M will be what? Positive. So once again, whatever the statement I explained previously, same statement justified here also. If you observe clearly, here sense of finding same. If you compare figure number 3 and figure number 4, I had taken references figure number 3 where coupling is negative. That negative is changed to positive. How it's happening? So if you see direction of current in coil A of your figure number 3 upwards, here also upwards. Coil B here it is downwards. Now what about in a coil B of figure number 4? It's upwards, no? So that means the direction of current is changed, no? Yes or no? Everybody? Yes or no?
Yes, sir.
Yes, sir.
If you see figure number 3 and figure number 4, direction of current in coil B is changed. It is downwards here, it is upwards here. So for the same sense of finding, once again, type of coupling can be changed by changing direction of current. See, one point only explained, but for explain that point, you can use these two figures, okay, or you can use a remaining two figures. It's your wish. You can use these two figures, or you can use these two figures. Not, I mean, everything is not necessary. All 4 figures are not necessary for explaining that simple statement. Is it clear, guys? It is up to you. You can use figure number 1 and figure number 2, or you can use figure number 3 and figure number 4. That's why I clearly wrote here or. Or means what? You can use this figure number 1 and figure number 2, or figure number 3 and figure number 4. Either this one or this one you have to use. Not all 4 all 4 figures are not necessary for explaining this statement. Okay, guys? So in this statement, I mean, is it clear, everybody? This is a point. For the same sense of winding, type of coupling can be changed by changing the direction of current. Is it okay? Okay, ma, everybody?
Yes, sir.
Yes,
Can you
sir.
proceed, or do you have any doubts? I'll give time now. If those who are having doubts, they can ask. Is it clear? Can I proceed, or is there any doubt, everybody? Can I proceed?
No, sir. You can
Okay, ma?
proceed.
So I think now this already we explained this note. What I explained this one? If 2 fluxes are aiding, what about that type of coupling? If 2 fluxes are aiding with each other, it is a
Positive.
positive
Positive.
type of coupling. If 2 fluxes are opposing, then which type of coupling?
Negative.
That's
Negative.
it. That's it. But the problem is, try to understand. But the problem is, can you able to see flux, guys? Can you able to see flux, Yogeshwaran?
No, sir.
Is it possible to see flux? I'm asking. Vimal? Hello, Vimal.
No, sir.
No, you cannot see the flux, right? You cannot see the flux.
Yes, sir.
So generally, if two flux are aiding, I can say it's a positive of coupling. If two flux are opposing, you can say negative of coupling. That's okay. But the flux is a invisible quantity. We cannot see the flux. Is it clear?
Yes, sir.
Then if you are not able to see the flux, then how can you decide type of coupling?
That true.
If you are not able to see the flux, then if two flux are aiding, positive you are saying. If two flux are opposing, you are saying negative type of coupling. I told you flux is invisible quantity. Then how can you decide type of coupling? Simply, you have to go for dot notation. Is it clear, guys? Why I have to use dot notation means since flux is invisible quantity, for deciding type of coupling, dot notation is used. Okay, so that only simply I wrote here. Please try to see this point. Dot notation. Otherwise, here please try to see. Flux is invisible quantity. So for deciding type of coupling, which one is used? Dot notation is used. Is it clear, everybody? Up to this, is there any doubt? Though it is a simple topic, but it's very important for me. So if you understand this one only, it is very easy. It is very easy for me to proceed. Everybody, is it clear? If you want me to explain once again. Okay, those are in doubt.
Yes, sir.
Completed, explained, or you want me to explain, or you want me to proceed?
Proceed, sir.
Very good, ma. Very good. Now my question. So I said dot notation is used for deciding type of coupling. Very good. But my question is, where you can assume dots? Generally, tell me. I'm just asking question you only. Tell me where you can assume dots. At the front end, back end. I mean, I can say.
Front end.
Okay.
end.
Don't tell me in terms of front end, back end. Tell me in terms of beginning end and ending end. Okay. So
Beginning.
tell me, we can assume dots at beginning end, ending end.
Beginning end.
Beginning, sir.
Any different answers? Everybody, please. Any different answers? Nirmala, Rahul, Vignesh, Shubha, Vidyavani. Where we can assume dots? Beginning end, ending end of a coil, I'm asking. Respond,
Beginning end,
please.
sir. Beginning.
Beginning. Is there any different answers? Shubha, Vidyavani.
No, sir.
Vignesh, I think Vignesh is very new, I think so. Morning, I did not able to see your name. Vignesh, are you able to listen my voice? Is it audible, Vignesh? Vignesh?
Yes, sir. Yes, sir.
Morning, I think you did not attend, right?
Yes, sir.
No, I'm asking simply, morning you came to class or not?
No, sir. No, sir.
Okay, no problem. Just try to...
Current entering point, current living point, sir.
Okay. Just try to take a video from your sir so that you can follow. Okay, now please tell me, guys. Everybody.
Current entering point, current living point, sir. Dot end.
You mean to say that beginning and okay, I'm asking where we can assume dots. Is it at the beginning end or is it at ending end? I'm asking. Simple question.
Sir, in A coupling, beginning end, and B coupling.
Tell me, no problem. Tell me your answer. What you are saying?
B coupling, leaving end.
Okay. See, very simple thing. Let me explain. See, guys, we can assume dots at beginning end or ending end of coils. It's our wish. Are you getting what I'm saying? We can assume dots at the beginning end of a coil or at ending end of a coil. Okay, it's up to us. But the thing is, suppose if you assume dot at the beginning end of coil in coil A, in coil B also you have to assume dot at the beginning end only. If you assume dot at the ending end of coil A, in coil B also you have to assume dot at the ending end. It's up to you. Is it clear what I'm saying? Everybody?
Yes, sir.
Yes, sir.
Assume dots at the beginning end or at the ending end of coils, your wish. Okay. But in my discussion, guys, I'm assuming dots at the beginning end of coils. It's not compulsory that you have to assume dots only at the beginning end. It's up to you, but anyone you have to follow. Suppose in coil A, if you assume dot at beginning end, in coil B also assume dot at the beginning end only. In coil A, if you assume dot at ending end, in coil B also you have to assume dot at the ending end only. That thing you have to understand. Okay. So, but my question, one second question. So what is the conclusion, guys? I told We can assume dots at the beginning end of coils or ending end of coils. It's our wish, right? Yes or no? But my question in my discussion, I'm assuming dot at the beginning end of a coil. So let me show that point in this point. After that, I'll explain. As told here, assume dots at the beginning end of coils or at ending end of coils. Okay, but beginning end of coil and ending end of coil. Tell me how you are going to decide. This is my question. Which one is beginning end? Which one is ending end? That one, how you are deciding? Anybody? Are you getting my
Current
question?
entering
Current entering direction.
point, it is taken as beginning end, sir.
Wherever current is entering, you are taking it as a beginning end. Huh?
Yes, sir.
Wherever current is leaving, you are taking it as ending end. Huh?
Yes, sir.
No problem. Just tell me any different answers, everybody. Rahul,
Yes, sir. Same, sir.
same
Current
answer. Huh?
entering.
Wherever
beginning.
current entering, you are saying it as a beginning end, right?
Yes, sir.
Wherever current leaving, you are taking it as ending end, right? Okay. So I'm just going to prove that it is not correct. Okay, let us see. I'm just going to prove that it's not correct. Let us see. So regarding your discussion, you said that wherever current is entering, it is a beginning end. So I think in figure number 1, if you see coil A, current is entering here. So tell me which end I had to write here? Tell me. Regarding your
Beginning end.
very good, ma. And what about this end, ma?
Ending.
Ending.
Ending end, right? Ending end. So I can write ending end, ending end, ending end. Okay. And what about this end?
Beginning
Coil
end.
beginning end. Very good. What about this end?
Ending.
Ending.
Ending end. Ending end. Okay. So very good. So I'll write simply beginning end means okay. Right. No problem. All right. Now see, that means if you decide, if you are deciding a beginning end comma ending end by seeing direction of current, so what you are getting indirectly in my example, I'm saying in my example, what you are getting, front end is nothing but beginning like that you are saying, back end nothing but ending like that you are saying, right? Front end beginning, back end ending like that you are getting. This condition should not be violated. Suppose if you see figure number 2, here current is entering, no. So regarding your discussion, what is this end, ma?
Beginning.
Beginning.
Here current is leaving. What about this end, ma?
Ending.
Ending end.
End. Here it is entering. What about this end? This end, ma? Entering,
Ending.
no.
Beginning.
Huh?
Beginning.
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 Now here condition is violated, no. If it is entering, you are saying beginning end. Already back end means ending end we wrote here, but back end means you are getting what is which one, ma? Beginning end. So please try to understand. So are you getting what I am saying? Suppose if you see here current is leaving here. Regarding your discussion, you can say this is ending end, right? You are writing it, you write it as ending end. So but it is conditions violated here. Front end is beginning end, but here you are getting front end is ending end. Back end is ending end, but here back end you are getting beginning end. It is not correct. Okay. So tell me, then how can you decide beginning end comma ending end? It is simply beginning end comma ending end decided by sense of winding, not by the direction of current. Please try to understand, ma. What is that? It is decided by sense of winding. Suppose example, I'll do one thing. Rahul is there?
Yes, sir.
Example one, Rahul is there here. Suppose Rahul is standing here. Don't worry. Okay, just for fun. Okay. So
Yes,
if you
sir.
take, if you take here, so what I'm saying is you started winding from this end. Are you getting, Rahul, what I'm saying?
Yes, sir.
You started winding on the core coil A. You are winding on core. You started from this end. Okay. So you started like this. Regarding your discussion, winding is going from the front side of the core. It is leaving from back side of the core, and it is I mean, one side it is entering at the front side of the core, leaving at back side of the core, entering at front side of the core. Like that, it is going on up to, and you are leaving right at back end. So in your discussion, tell me, Rahul, where you started here, no?
Yes, sir.
That means in our discussion, beginning it is here. For you, beginning it is this one, no? For
Yes, sir.
you, beginning is this one, okay? And for you, ending it is this one, no? Yes,
Yes,
no?
sir.
Yes, no? Because you started from this, you wounded like this, you just ended this one here. So regarding your discussion, beginning it is this one, ending is this one. Is it clear?
Yes, sir.
So no, suppose, let me take some other person. Hello. Is there any, Anu, can you able to, Yogeshwaran, is there? Yogeshwaran?
Yes, sir.
Suppose, I think I'm having one person, Yogeshwaran, okay? He's standing here. Okay, guys? So same coil A, instead of starting from here, he started wounding from here, from this side. Are you getting what I'm saying? Yogesh, is clear, my Yogesh?
Yes, sir.
You started like from this end. First of all, you started wounding. Coil is wounded from the back side of the core and leaving like this, and back side of the core leaving like this, back side of the core leaving like this, back side of the core leaving like this. Yes, you are going on, and back side of the core and leaving like this. So tell me, Yogeshwaran, in your discussion, which one is beginning into this one or this one? First one or second one?
First one, sir.
Very good, ma. So in our discussion, this is nothing but I can say beginning it, right?
Yes, sir.
And what about this one?
Ending.
Ending. Everybody. Is it clear, everybody? Hello? Nirmala? Mohan
Sir.
Priya? Clear? Understood, ma? This one?
Sir.
Please tell me. It's very important. I'm saying. That's what I'm saying. So is it clear? Is it clear, everybody?
So you are telling that is chosen by.
It is purely by the sense of winding, I'm saying.
Okay, sir.
Which
Yes.
one is beginning end, which one is ending end is decided by not by direction of current. It is purely by the sense of finding. Suppose the example regarding Rahul, he will think that front end he will take it as a beginning end, back end he will take it as ending end in this discussion. Suppose Yogesh will take ending end as back end as beginning end, and he will take front end as ending end. Is it clear what I am saying? Yes or no, ma?
Yes, sir.
Everybody, is it clear?
Yes, sir.
Respond, ma, please. I'll let me spend some time here because it's very important. So tell me, Rahul. Okay, Vignesh, is it okay for you? Shobha,
Okay, sir.
Yavani, Muthu Krishnan. Understood, ma? This one.
Yes, sir.
Yes, sir.
Ultimately, what I want to say is beginning end, ending end is decided by sense of winding, not by direction of current. That's it. Okay. And suppose in my discussion, I'll take front end as beginning end and I'll take back end as ending end. Okay. That is not compulsory. You can take reverse also. You can take back end as beginning end. You can take front end as ending end. It's your wish. But anyone you have to follow. Are you getting what I'm saying?
Yes, sir.
Okay, very good. Now let me erase this portion.
Sir, one
Please,
doubt,
please.
sir. Sir, from my point, if I am starting winding, like you said, which means the direction of current will also be changing, no, sir?
Regarding you, miss, regarding Rahul, huh?
Yogesh, sir, from here.
Okay, so tell me what you are saying.
From this
No,
point,
this
if I start
current
winding.
is decided by what source, no?
Okay, sir. Yes, sir.
Yeah, neutral phase is there. No? That depends on the, direction of your, it is depending on the source. If it is phase neutral, the current will be flowing like this only.
Okay, sir. Yes, sir.
Okay, right now. Very good. So let me proceed. Let me erase this one, so you'll be having some confusion here. Okay. Now, what I'm saying in my discussion, as I told you, I'll take front end as beginning end. I'll take back end as ending end. Okay. It's not compulsory. You can change also, but I will be following like this. So please simply try to help me out here. Wherever front end is there, I'll write simply here. Which one, ma? Tell me. Beginning end. Back end is there means what I have write here? Ending end. Front end, beginning end. Back end, ending end.
Ending.
Front end, beginning end. Back end, ending end. Front end, tell me, ma, what I have write here? Tell me, beginning end, no? Back end.
Back end.
Ending end. Here, front end.
Ending
Which one I have right here? Beginning end.
Beginning
Back end.
end. Ending end.
Back end. Ending end, no? Front end.
Yes, sir.
Beginning end. Here,
Beginning
front
end.
end. Beginning end.
Beginning end.
Back end.
Ending end.
Ending. Here, back end. Ending. Front
Beginning.
end.
Ending end.
No, I'm saying back end, ending end. Okay. Front end, I'm saying front end.
Beginning,
Beginning
sir.
end.
Okay, right. So this thing I wrote here, please try to see here. Everybody, assume dots. Please, everybody see on the screen. Assume dots at the beginning end of coils or ending end of coils is our wish. But beginning end of coil or ending end of coil is decided by what, ma? This is very important. So let me underline this point, or let me highlight this. Tell me, beginning end, beginning end of a coil or ending end of a coil is decided by what? Everybody, decided by what? Sense of winding, not by what?
Direction.
Not by direction of current. And one more thing, type of coupling can be changed by changing direction of what? Current. That already explained, you know. Okay. So now tell me, in our discussion, guys, in our discussion, we assumed front end as which one, ma? Respond, please.
Beginning.
In our
Beginning
discussion,
end.
front end is taken as beginning end, and back end is taken as a
Ending end.
ending end. And one more thing I told, we can assume dots at the beginning end or ending end, your wish. So let us discuss. It's up to you only. But let us assume dot at the beginning end of a coils. What is that? Let us assume dots at the beginning end of coils. Please tell me wherever beginning word is there, just try to keep dot. That's it. In coil A, beginning is this one. Let me keep dot here. 1 minute. Right. Let me keep dot here. And so I think dot, while keeping dot, some problem with cursor. Try to have patience. Right. Okay. And coil B, guys, which one is beginning? This one, no? This one. Okay. Let me keep dot here. Like that everywhere. So here beginning is the no dot. Here beginning is the no dot. Here beginning is the no dot. Figure number 3. Okay. Okay. In figure number B, beginning is here dot. Okay. In figure number 4, beginning is here dot. In figure number 4 only, coil B, beginning is here dot. So now we'll get one exact definition for positive type of coupling, negative type of coupling. 1 minute more. So please let me complete this dot notation, dot marking. I think here it is missed. Now tell me, guys, everybody. So tell me in figure number 1 is which type of coupling, positive or negative? Already we made a discussion. Tell me.
Positive.
Positive. Okay. Everybody positive, no? Nice. Now please tell me, let me ask a simple question. So in figure number 1, in coil A, current is entering a dot or leaving a dot?
Entering, sir.
Entering a dot. What about in coil number B? Current is
Entering,
entering
sir.
a dot or leaving a dot?
Entering.
Entering. Very good. That means, what is the definition I can give for positive coupling? If current enters the dot in both the coils, or current leaves the dot in both the coils, so that can be called as positive type of coupling. In this example, I can say figure number 1 is there, and if you see figure number 4, guys, current is entering here at a dot in coil A. Current is so I think dot missed. Excuse me, please, ma. I think here dot missed here. I told you how to mark dot at beginning of coil. Okay, right. So now please, yes, current is entering a dot of coil A. In coil B also current is entering a dot only. That means that both the coils at dots current is entering. So that means whenever current enters the dot at both the coils or current leaves the dot from both the coils, it is a positive type of coupling. Is it clear, everybody? Respond, everybody.
Yes.
Yes,
Now
sir.
let me see figure number 2, Amma. Figure number 2 and figure number 3. Please try to see figure number 2. In figure number 2 at coil A, where current is entering, ma? Dot.
Entering the dot.
Entering a dot. Whereas from coil B, if you observe, from dot is leaving or entering?
Leaving.
Leaving.
Very good. In coil A at a dot current is entering, whereas in coil B at a dot current is leaving. If you see nothing but which type of coupling? Negative type of coupling. Yes or no? If you see figure number 3 also, in coil A current is entering a dot. In coil B current is leaving from dot. So which type of coupling? Once again, tell me.
Negative type.
That
Negative
means,
type.
so let me please tell me the definition for a type of coupling. Let me conclude here so that I'll go for Lenz law. Everybody on the board, yes, tell me now. Positive type of coupling definition means very simple. So let me highlight this. If current enters the dot in both the coils or leaves from the dot in both the coils, I'm saying both the coils. Okay, are you getting what I'm saying? I'm saying both the coils. In both the coils, current has to enter. In both the coils, current has to leave. Okay, you can both the coils, current has to enter, or from both the coils, current has to leave. Then it is which type of coupling, ma? Positive type of coupling. What are negative type of coupling? Negative type of coupling is what? Yes. Tell me, negative type of coupling means what here?
Current enters.
Let me highlight this one. If current enters the dot in one coil, whereas leaves from the dot in another coil, It is which type of coupling?
Negative.
Negative type of coupling. That's it. Okay. So in this whole discussion, I'll ask only 2 questions to you. So after that, I'll go for next topic. Okay. So please tell me, for the same sense of winding, though sense of winding is same, how can you change type of coupling? That's my first question. Rahul, everybody, tell me first of all, Rahul.
Changing the direction of current, sir.
That's it. And one more question. So beginning end comma ending end decided by what? Nirmala. Beginning end
Front
comma
end.
ending end is decided by what? Decided by current direction of current or sense of winding?
Front and back and the sense of
I'm
winding,
asking
sir.
a simple question. Please let me listen. Please wait. Listen my question clearly.
Okay,
Beginning
sir.
end comma ending end decided by what? Is it direction of current or sense of winding? That means you are saying front and back like that. You are saying that for that one
Sense-
terminal is that sense of
Sense
winding.
of winding, sir.
Okay, very good. Sense of winding. That's it. These 2 points are enough. And one more thing. Definition for positive coupling, as I told you, if current enters the dot in both the coils or current leaves the dot from both the coils, it is a positive type of coupling. Negative type of coupling means if current enters the dot in one coil, whereas leaves from the dot in another coil, it is a negative type of coupling. That's it. Can I go for Lenz law? Is there any doubts till now? If you are having doubts, you can ask me up to this. Then if you are not asking, I'll go for next topic, Lenz law. Can I proceed?
Yes, sir.
Everybody, can I proceed, ma?
Yes, sir.
So especially Lenz law topic is very, very important. I'm saying, please don't sleep. Those who are sleeping, you have to get up. Okay. So our total transformers subject will come here. Yeah, should be very careful with arrow marks. Whatever the information required that already given, you have to respond. That's it. If you are responding in a proper way, I can think that you really understood the subject. Can I start?
Yes.
Yes, very good. Okay. Okay. Everybody. See, so as I told you guys, it is a phase, it is a source I had connected to this winding, and everybody knows that. I already told you in the last class. Tell me, in a source, everybody, in a source at a neutral point, current enters or leaves. Step by step, I'll ask. You have to tell answer. Okay, simply I'll ask the question. Enters. Very good, very good. And from phase, it will leave.
Leaves.
Leave,
Okay.
sir.
So I can take phase as for understanding purpose. I'll take phase as a plus terminal and I'll take neutral as a minus terminal. Okay, guys? Up to this, okay now, everybody?
Yes, sir.
Okay, ma? See, very good. See, actually in a offline, if it is offline class, this much slowly I won't go generally, but since it is online class, I should think about your student. I should think about students also. That's why I'm just going very slow, but you please respond so that it will be good for me also. Okay, right. Now, first of all, let me ask one question. I think after connecting a voltage source to the primary winding of transformer, generally it will take one current. What is that current I told?
Magnetizing current.
Very good, ma. Magnetizing current. Magnetizing current. Okay. Magnetizing current. Wait. I call this current as magnetizing current. I mu. Okay. I mu. So now tell me. So let me take this one as a core. This one is a core. This white color border. White color. Let me take this a core. And this I just wounded winding like this. Tell me your winding is going. Okay, guys. If you really understand the subject, tell me what about this end? I should write a front end or back end?
Front end, sir.
Front end.
Very good, ma. Front end. What about this end, ma?
Back end.
Very good. Back end. What about this end?
Front end.
Front end.
Front end. Very good. This end, please.
Back end.
Back end. Very good. Now, I think in our discussion, we assumed front end as which end?
Beginning end.
Ending.
Beginning.
Beginning end. Wherever front end is there, I can write simply beginning end. Wherever back end is there, I can write what, ma? Ending end. Back end is there, here I can write it as ending end. Very good. Now tell me, current is entering at the front end or back end in this case?
Front
First
end.
case,
Front
front
end.
end. That means you have to use figure number 1 or figure number 2.
1, sir.
Everybody respond.
1, sir.
Yogesh,
One, sir.
1. So it is entering, right? It is entering at a front end. Yes, very good. It is entering at front end. Whereas leaving at back end, no, that we cannot see this arrow mark. Are you able to see this that arrow mark current direction which is leaving from back end? No.
No, sir.
Yes, it is leaving at back end. 1 second is entering at front end, leaving at back end, 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 entering at front end, leaving at the back end. Very good. Is it clear up to this, everybody?
Yes,
Please
sir.
respond.
Sir.
Yes, sir.
Okay, okay, ma. Okay. And if you want, you can place dots also, nothing wrong. You can place dots also. Let me keep dots also, guys. Let me keep dots also. What I told, we have to assume dots at the beginning end in our discussion, right? It is beginning end. Let me keep dot here. Okay. And here is beginning end, no? Beginning end. Let me keep dot here. Right. Sorry. Okay. Now tell me, excuse me, yeah, if direction of IME is like this, guys, I already told you, I'll write that sequence also for your understanding point of view once again. So please tell me, whenever V1 is V1 is connected, V1 is time variant, time invariant, voltage source, AC,
Time
no?
variant.
Time variant, or what is the other name for this time variant, or I can say AC, no?
AC.
Yes, sir.
Whenever V1 is time variant, current taken with the transform, that's what IME, you know, magnetic current. It is also what I can say time variant, no? Time variant, or I can say AC. So because of time varying current, flux produced in transformer core is what? AC or not? Time variant or time invariant?
Time variant.
Time variant, or I can say AC. So whenever this pi is a time variant, now tell me, because of this pi, you will get E1 induced primary winding. Yes or no, ma? Because E1 proportional to what I told, rate of change of flux is d by dt of what is it?
N5.
N1 into
N5.
pi.
N5.
So let me take number of turns here N1, number of turns in secondary winding N2. Okay. Whenever pi is time variant, so N pi will be time variant, EMF will be induced, not induced. Tell me.
Induced.
Induced. So let me show that EMF here. I'm just showing that EMF here. Let me show that EMF here. You have to follow step by step because so many arrow marks will come here. If you suppose sleep for 5 minutes, no. If you get up, then you cannot understand. You may think that it is a Malayalam movie. Okay, you cannot understand. All right, see. Is it clear, everybody? Okay, everybody.
Yes, sir.
Respond, please.
Yes, sir.
Okay, right. Okay. That's what I can say. E1 value, E1 value. Okay. Now what I am saying is, whenever E1 is coming, guys, due to this E1, do you get, let me ask one question. If there is a closed path, do you get current? Yes or no? Because of this E1, I am saying, if there even here closed path is a no. Whenever V1 is connected, IMU is coming, flux pi is there. First of all, can you let me do one thing? Before explaining regarding remaining things, first of all, tell me direction of flux from yours. It's up to you only. You have to tell answer. Direction of flux will be what? Upside or downside? For this direction of current, okay, if current is entering at the front end, tell me direction of flux, upwards or downwards?
Upwards, sir.
Upwards, sir.
Figure 1, no, this one you have to use. Figure 1 or figure 2?
Once.
1, no, you have to use this one, right? You have to hold this core in this manner. So where this arrow mark indicates direction of this current and the thumb indicates direction of flux, no, upwards. Please let me show direction of flux first of all here. Upwards. This is what I can say, flux upward. Okay, I am just writing wait. This flux is nothing but what, ma? Flux pi, no? Pi. So it is taking path like this. Pi. Taking path in this manner. Tell me in the, at this whenever it is linking secondary, are you getting a direction of flux downwards, upwards? This pi it is coming like this, coming like this, coming like this.
Downwards.
Downwards.
Downwards, sir.
Downwards.
Very good, very good. Downwards. Now here it is going from right to left. Right to left. Right to left. Okay, guys. Up to this, do you have any doubt? Please let me know. After that, I'll proceed.
No, sir.
No, sir.
So V1 is time variant, IM is time variant, flux is time variant. So rate of change of flux is possible. EMF will be induced here. And I told you there is closure path in primary side. Because of this EMF E1, you will get some current. I call that current as IX. What is that? IX. I'll call that current as IX. Okay. Because of the IX current, you will get a flux. I call that flux as a pi X. Is it clear, everybody? Yes or no, ma?
Yes, sir.
So now let me ask one question before proceeding furtherly. So what is the type of EMF induced in this primary winding? What is the type of EMF? This one statically or dynamically? In transformer, I'm asking. Transformer.
Statically induced. Yeah.
Static, sir.
So direction of this EMF E1 or direction of this IX, which is because of this E1, is given by what? I get my question. Direction of statically EMF E1 or direction of IX current, which is because of this E1, is given by which rule or which law? What happened here? Direction of
Lens law, sir.
our heading by what, you are sleeping or what? See, I am discussing about Lenz law only. No, our main heading is this one. Then why you are not replying? So direction of statically EMF is given by what? Lenz law only. No, yes or no?
Yes, sir.
Now please let me study step by step this line. Everybody, time varying. Okay, let me use highlighter. Okay, just listen. Yeah, time varying flux. Tell me, guys, in our discussion, what is the time varying flux, ma? I think this one, no? Time varying flux means, I think this one. Is it yes or no? Wait.
Sir.
Yes, sir.
1 minute. Let me use pen here. Okay. This one, right? Time varying flux is this one, no? Very good. Whenever time varying flux linking a coil, it is linking with whenever time varying flux linking this primary winding, it induces an what? EMF in the coil. What is that EMF? Please try to respond. Time varying flux linking this primary winding. I said that EMF is induced in the coil. No, what is that EMF?
Static EMF.
E1, sir.
E1, very good. E1. Okay, E1. When the coil circuit is closed, yes, no doubt this closed. I mean, closure path is there in this coil. Okay, in this circuit, closure path is there. When coil circuit is closed, 1 minute. Let me erase this portion. Okay, yeah. Whenever the coil circuit is closed, a current begins to flow in the coil. Tell me, what is that current name I had given here? EMF will be induced, okay. And whenever coil circuit is closed, I told you some current will flow. What is that current?
X.
IX, very good. IX. A current begins to flow in the coil. Very good. Then next, the direction of this induced current and direction of this IX or induced EMF or E1 is given by what? Tell me, is given by
Lenz
what?
law.
Lenz law. Lenz law. What Lenz law will say means very simple. According to this law, very simple. The induced current develops a flux. Tell me, this induced current IX develops which flux, ma? What is the name of flux?
Pi
Induced
X.
current
Pi
IX
X.
develops a flux pi X, no? Pi X, which always opposes the change responsible for inducing this current. Tell me, this pi X is going to oppose one person. Who is that person? Tell me, who is that person responsible for getting this IX E1? Tell me, who is the person responsible for getting this E1? Pi. Yes or no? Therefore, in this whole discussion, pi is your cause and pi X is your effect. I understand what I'm saying, ma? Everybody? Is it clear, everybody? Yes or no? Respond, please.
Yes, sir.
Sir.
Yes,
This
sir.
becomes cause and this becomes what? Effect. Okay. This becomes cause and this becomes effect. So what I'm saying, effect opposes, mean always it develops a flux means pi X, which always opposes this change responsible for inducing this current, means This pi x is going to oppose your pi. That's it. If you really understood, I can proceed. Understood or really, everybody? Can I proceed?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now tell me, if you really understood, let me ask one question. So as you said, according to Lenz law, direction of E1 or direction of Ix is given by Lenz law, I said. What Lenz law will say? Sir, if there is closed path, because of this E1, you will get some current Ix. Due to this current Ix, we will get some flux pi x. This pi x will oppose pi, like that we are saying, right? Now tell me, in this portion, what might be the direction of pi x? Is it upwards or downwards?
Downward, sir.
Downward, sir.
What? Downwards, upwards, sir?
Downwards.
Tell me, openly tell me, no problem. If it's
Downwards,
not
sir.
issue. Downwards,
Downwards.
upwards, sir? Downwards. Why it is downwards, guys? Everybody?
Opposes
It
the
opposes the direction.
cos.
It opposes whom?
Cos.
Pi, sir.
Cos.
Pi. Pi means, I mean, please say, no, don't say cos. Please try to say, what is that cos? Pi, no? Yes,
Yes,
pi.
sir.
So, direct, this is a green color, nothing but I can say pi x, okay? Pi x, I can say. It should be opposing your pi. It is upwards here, so it is coming downwards here. So, very good. Now, please complete this path. What about here, arrow mark? Right to left or left to right? Left to right. And what about in this portion? Upwards or downwards, sir?
Upwards.
Upwards. Now here it is opposing pi, no? So direction from right to left or left to right? Right to left.
Right to left.
Yes, yes, yes. This is what I can say, pi x, pi x. So then immediately some people will get doubt. Sir, do you think that pi x is getting because of ix, or after getting pi x you are getting ix? So very simple, see. Which one is coming first, ix or pi x? Ix is coming first. Due to ix, pi x is coming. Due to pi x, ix is coming. Everybody respond.
Ix.
Due to Ix.
Due to ix,
Some Ix. By X.
due to ix, then pi x will come. But before showing ix here, I am just showing here pi x. Very simple. The reason is very simple. For making you to understand, for making you to see easily, you already know that according to Lenz law, effect opposes cos. So that's why obviously pi x will be opposite to pi. That's why for you making you to understand, I am just indicating pi x first. To be frank, before showing this pi x, ix is there. Ix is there. Now tell me, in this primary winding, I got pi x direction downwards. If I want pi x direction downwards, tell me where ix might have entered, back end or front end. Question to you. Are you getting my question? Yes or no, yeah? Please respond.
Yes, back end entering.
Back ends.
Everybody, is it clear? Is it clear, everybody?
Yes, sir.
Yes, sir.
Yes or no? Please use whatever the, I mean, I already told now. So simple. Suppose you just hold this, everybody. I'll explain one second, please just listen. Just see. Everybody, please try to come to this primary side. I'm just deciding direction of ix, means in what ix is entering at back end of front end. I'm deciding. Okay. Now further, what I'm saying is, we already know that pi x is downwards, so thumb should be downwards. You please hold a core. So please hold this core. Okay, this should be held by your hand, such that your thumb should be downwards. Please try to practice, ma. Your thumb should be downwards. Tell me at that time your wrapped fingers are going at the back end of the core, or your wrapped fingers are coming above the core, below the core.
Below the core, sir.
Very good, ma. Very good. That means you are holding core. Okay, on your palm, on your on your wrapped fingers, core is there. Yes or no? That like that you have to hold your core. So it will be downwards. Is it clear, guys? Or those who are having doubts, everybody, those who are having doubts, please try to see this figure number 2. Are you able to see figure number 2, guys?
Yes, sir.
Hello, are you able to see figure number 2?
Yes, sir.
Please
Yes,
try
sir.
to rotate this. I mean, I can, if I go back, we'll be having some confusion. Are you, everybody, is it able, are you able to see this direction of ix is entering at back end? Is it understood to everybody? Is it clear, everybody, or you want me to explain? Everybody, please respond.
Clear, sir.
Nirmala, Rahul, Vignesh, Subha, Vidyavani.
Clear, sir.
Clear, sir. Yes, sir.
Everybody getting direction
sir.
of ix.
Clear,
should
sir.
be, it should be entered at the back end. Yes or no?
Yes, sir.
Sir.
It should enter at back end. If current is entering at back end, then only your pi x will be downwards. Yes or no? So now please let me decide. Let me show the direction of ix. Ix. Okay. Please tell me. Let me decide direction of ix. So what you said? It is entering at back end or front end? Tell me back end. Which one is back end? This one or this one? Front one or two? Tell me, here back end is this one, this one. Can you able to see, right? This one is back end, right?
Yes, sir.
So here it is entering. Ix is entering. Just wait. Ix is entering like this. It is entering at back end, leaving at front end. Okay. Entering at back end, leaving at front end. 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 So this is what direction of what, ma?
Ix.
Ix. Everybody, is it clear? Yes or no?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now let me ask a simple question. So guys, everybody, so let us see this right side. I'm writing something here. Suppose if a source is there like this, okay, otherwise I'll do one thing. Let me draw in a different way. Okay. Suppose guys, if a source is there like this, okay, and tell me if current entering from bottom, if current leaves from top terminal like this, okay, like this. Now among this, which one is plus, which one is minus, ma? Tell me from your with your knowledge. If it is a source, I'm saying if it is a source. Tell me which one is positive, which one is negative. This one is what?
Top is
Leaving
positive.
is positive, sir. Entering is negative, sir.
Very good, ma. Now use same knowledge and tell me. Here I'm asking a question. I'm just taking example. This source example, source E1 is there. If source E1 is there, and if it is entering at bottom, if it is leaving at top, you said that positive terminal should be marked with the plus, and the bottom terminal should be marked with the minus, you said, right? Now please everybody, you consider this entire primary winding, this winding as a source in place of this. Okay, so let me highlight, excuse me, highlighter. Oh, I'm using same color. Okay, let's see. No problem. Okay, right. See, you please try to highlight this portion. Okay, otherwise you'll be having some confusion. This. So I'm saying this entire winding should be replaced with a source. I'll assume that in place of a winding, you are having some source. Some source is there. Some source is there, like this. You know what, I can take because no problem, because I said no. What is the EMF into the primary winding? Even no. That means entire this winding can be taken as a source. Nothing wrong. I can take. Okay, I can take entire winding. This one as a this winding can be taken as a source. Okay. What is the source voltage here? What is the EMF induced across primary winding? Tell me, what is the value? Hello. What is the induced EMF induced in the primary winding? I'm saying here. E1, no. Why you are thinking E1?
Yes, sir.
E1, why you are thinking? Yes, E1 value. Now, please be careful. If you observe clearly, guys, here, now I think those who really followed, they can answer this question. Okay. If you take this one as a source, I said Ix direction. Please try to see this green color direction. It is entering at back end, leaving at front end. 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 Now please tell me, current is going from bottom to top or top to bottom? Everybody, this Ix current is going from bottom to top or top to bottom?
Bottom to top.
Everybody listen. Yogeshwaran.
Bottom to top.
Bottom to top, sir.
Everybody clear? Any doubt in that?
No,
See,
sir.
Ix it is entering like this, going like this. No, bottom to top it is going, right?
Yes,
that means that only I am showing here like this. Ix is it is entering at the bottom, leaving from it is top, it is leaving. Okay. So already you know if it is if source is there, wherever it is entering, I can take it as which terminal? Minus terminal. It is entering wherever current is leaving, that terminal can be taken as what? What ma? Plus. Yes or no? So this terminal nothing but plus, nothing but this one is nothing but what ma? Plus. And what about this one nothing but minus? So nothing but this one nothing but what ma? Minus. Like that, I am deciding polarities of this G1. Is it clear, everybody? Yes or no?
Yes, sir.
Yes,
So
sir.
same thing. If you observe clearly, nothing I did. Very simple. So this diagram I just retrying once again here. See, this is a source. This is a source having voltage how much? Voltage how much, ma? V1 value. Okay. Direction of current is I mu is like this. Here phase neutral. It is nothing but I told you na E1 voltage. Let me use different color. E1 voltage. This is the direction of Ix is like this. Can you able to see this portion only? No, here it is there in this diagram. V phase neutral, yes, phase neutral. V1, yes, V1. E1 is a voltage source. E1 is a voltage source. I mean, plus is here, minus is here, plus is here, minus here. I mu and Ix they are opposing, they are aiding. Opposing, aiding, amma. I mu and Ix.
Opposing.
Opposing. Okay. Now tell me, I'll ask a simple question now. Let me conclude here. Let me conclude this topic, everybody. So please tell me in primary side, what is the relation you are going to write? V1 bar equal to what? Is it E1 bar or minus E1 bar? Tell me in primary side, plus minus, V1, E1. Tell me V1 bar equals to E1 I should write. V1 bar equals to minus E1 bar I should write. This is a question to you, everybody.
V1 equal to E1.
V1 equals to E1, V1 equals to minus E1. Everybody, please tell me.
Equal to E1.
Ma? Please be active. See guys, everybody.
Minus T1, sir.
I mean, V1 equals to E1, Okay, see, very simple. Suppose guys, if we don't have any Ix current here, suppose in this arrow, in this figure, if we don't have any Ix, no. See, if you are having only V1, if you are having only E1, if you are having only I mu, then simply I can write, as you said, V1 bar equals to E1 bar, I can write, there is nothing wrong in that. But here, this V1 bar equals to E1 bar is correct. According to circuit theory point of view, it is correct. KVL equation. Is it clear? But be careful. Regarding field theory, it is not correct. Why means here, you know, effect is opposing cause. Here cause means I can take V1 can be taken as cause here. Effect means I can take E1 can be taken as effect here. Or I mu which is due to V1 can be taken as cause here. And Ix which is due to E1 can be taken as effect here. Is it clear guys? So tell me this effect opposing cause, no? Ix is opposing cause. Please try to see this arrow marks. Are you able to see this arrow marks? Everybody? Respond,
Yes, sir.
please. Everybody respond, ma.
Yes, sir.
Tell me effect opposes cause or effect the opposing cause or not? This one. I mu and Ix they are opposing or not opposing?
Opposing,
sir.
sir.
To show that opposition. Ix opposing I mu means indirectly E1 is opposing V1 only. Because Ix is due to E1. I mu is due to V1. So E1 is opposing a V1. To show that opposition, I need to keep here minus symbol. So according to Lenz law, what Lenz law says? Effect opposes cause. So this minus symbol why I'm writing means this is because of which law? Tell me because of which law?
Lenz law.
Lenz law. Because of Lenz law. I need to indicate that effect also. Your Ix is opposing I mu, that I need to indicate here. And E1 is opposing V1, that I need to indicate here. So to show that opposition only, so nothing but to show that Lenz law only, nothing but effect opposing cause, that I want to show mathematically. That's why I'm using here minus symbol. Everybody, is it clear? Everybody?
Yes, sir.
I'm expecting answer from you guys. Is it clear?
Yes,
Everybody?
sir. Yes, sir.
Very good, very good. Now, if you really understood this one, tell me this side portion. Okay. Forget about this green color, ma. Forget about this green color. Pi x plus don't think about pi x. Let us start with starting once again, starting onwards. tell me guys, everybody, first of all, which type of source is connected to this primary winding of transformer? V1, time variant, or I can say AC. Because of V1, what is the current taken in the transformer? I mu, time variant, or I can say AC. Because of the I mu, which type of flux you will get? Pi. Is, I mean, this flux is time variant, or I can say AC. So I told you in primary side already E1 is induced. Leave it. I'm discussing about secondary winding. Tell me, because of this pi, you will get EMF into secondary winding. Let me take it as excuse me. Let me take it as E2, E2. Okay, E2. So why E2 is possible here? E2 proportional what I said, d by dt of N2 into pi. Whenever pi is time variant, yes, E2 will be induced here. Is it clear, everybody? Clear or not, everybody?
Yes, sir.
Yes, sir.
Very good. Whenever, because of this E2, you will get current in secondary side if there is closed path. Tell me, closed path is there or is not there in primary, in this secondary side?
Is close,
Or
sir.
not?
Yes,
Close.
sir. Yes, sir.
Close.
There no closed path is there? No, because I connected some load there. If I'm using a load, by using load, I just provide a closed path here. I provided a closed path because of connected voltage. So sorry, because of connected load there. So V2 can be taken as a load voltage. Okay. Now what I'm saying is, because of this E2, if there is closed path, you will get some current. That current can be called as a I2. Very simple, ma. Previously, because of E1, I got IX. No, like that here, because of E2, I am getting I2 current. That's it. Because of this I2, you will get some flux of pi 2. Okay, pi 2. So now tell me, this pi 2 is going to oppose which one, ma? Pi 2 is going to oppose which one? Which flux? According to this, once again, same time varying flux. Yes, time varying flux.
Pi,
Linking
sir.
the coil, linking a secondary coil, induces an EMF in the coil, induces E2 in the coil. Okay, when the coil circuit is closed, a current begins to flow. Yes, I2 begins to flow. Okay, the direction of this induced current, the direction of I2 or E2 is given by Lenz's law. According to this law, the induced current I2 develops a flux pi 2, which always opposes change response for induced this current. It will oppose pi 2 opposes pi. So in my discussion, pi 2 is effect, and which one is cause? Everybody, guys?
Pi.
Explaining, tell me, fast,
Pi.
fast.
Pi.
Pi is a cause.
Cause.
Pi is cause. Pi is cause. So obviously pi 2 is opposing pi no. So now tell me, in this portion, direction of pi is downwards, upwards, amma? Direction of pi downwards, upwards, yellow color.
Downwards.
Downwards. Downwards. So please, you have to show direction of pi 2 is upwards or downwards.
Upwards.
Very good, upwards. So this is what I can say, pi 2. Okay. So it is coming like this, pi 2. Okay. And coming like this. Here arrow mark will be downwards, no? Downwards. Here left to right. Yes. Now see. Okay. Is it clear? Everybody. Understood? Now please, as I told you, because of this core flux, yellow color flux pi, you got some EMF E2 here. Let me show first of all that EMF in the secondary side of secondary winding. E2 is the EMF induced in secondary winding. E2. Okay. Now tell me, guys, if I want pi 2 should be upwards, pi 2 should be upwards, pi 2 should be upwards. So tell me, this thumb should be upwards means, thumb should be upward means. So tell me, in what direction I2 might have entered? Question to you. Yogeshwaran?
Left to right, sir.
No, I'm asking, pi 2 is upwards. Pi 2 you are getting upwards. Why you are getting pi 2 upwards means pi 2 is opposing pi no. That's why upwards, that is okay. If please use right hand thumb rule and indicate thumb in this manner. So same figure I'm saying, this figure. Indicate thumb upward direction, in this direction. Hold your core like this, in this manner. Tell me where current will enter. It is entering at back end or front end if I hold like this.
Front end, sir.
No, please try to
Back
see.
end, sir.
Back end.
I told now. Image number 2 means this one only, guys. If I hold like this means what is the meaning? We are current is entering at back end or front end?
Back end, sir.
Back
If
end.
you are having doubt, I'll show you. See, let us see. I2, it is entering at back end, leaving at front end, direction of current, leaving at front end, 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 leaving at front end. Yes, leaving at front end like this. So current coming like this. Yes, this is direction of current. If you want, you can check here. See here arrow mark. Are you able to see this arrow mark? Which I'm just writing on this image. Everybody? Hello? This arrow
Yes,
mark,
sir.
you are able to see? What
Yes,
this
sir.
arrow mark indicates actually? Direction of current, no?
Yes, sir.
Here, try to see this red color arrow marks also. Same or not?
Yes, sir.
That means if you want flux pi to upwards, you have to hold core in this manner. So that means current is entering at back end. It is entering at back end, leaving at front end like this. Okay. Now once again, same question I'm asking you guys. Let me ask same question. Please wait. Let me erase because I need some space here. Okay. Can I erase this portion? Okay, right. So please, in place of secondary winding, please connect to some source so I can understand easily. In place of secondary winding, please connect some source having the source voltage E2. E2, okay? So please. Okay, ma. Everybody see here? Everybody? So let me connect some source. Here source is there. What is the source voltage, ma? I said how much? E2 value, right? E2 value. Here already, I think, let me, if you want, I can I write here? Is there any problem for you? Let me show here. Let me show that the source here so that you'll be having some easy for you to understand. Okay, right. Everybody, just like this, in primary side, I just showed E1 source. Like this, please tell me in secondary side also I'm asking. Secondary side also, let me connect some source here. Having what is how much? E2, and so let me, in place of winding, let us assume this winding can be taken as a source because across winding some EMF is induced. So you can take this winding as a source here. Okay. Now tell me here direction of current is from bottom to top or top to bottom. Once again, same question I'm asking. Tell me. Direction of current, bottom to top or top to bottom?
Bottom to top.
There is nothing to confuse here. Very simple. I think you people are afraid by seeing this flux lines only. Okay, see, it is entering at back end, leaving at front end, 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 entering at back end, leaving at front end. Like this is coming. That means what? Current is coming from bottom to top or top to bottom. In this case, in this winding.
Top to
Guys,
bottom to top.
Very
Bottom to
good.
top, sir.
Bottom to top. Bottom to top means when 1 minute, please, ma. Bottom to top means, so I think yes, bottom to top. You tell me here, whenever current is flowing from bottom to top, what is that current name here? I2, na? I2. Here also I2. So what about this terminal name, ma? Minus or plus? Tell me, guys. This terminal, this minus. This one, ma?
Plus.
Very good. Now, what about what is? I mean, it is connected to what? I sense load. No, it is connected to load. 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 Nothing but load. KLOAD, load. Okay. And what about load? What is I taken? How much I taken? V2, right?
V2.
V2. Okay. So that means let me show this arrow marks here also for your understanding point of view. Downwards, it is entering here from bottom to top. It is going like this. Okay. Here it is a plus. Here it is minus. Please, guys, this plus only I'm just showing here. This minus only I'm just showing here. This voltage is nothing but E2 voltage. Okay. And I'm asking very simple basic question I'm asking now. Please tell me, at load, always current flows from positive to negative or negative to positive? I'm asking about load, guys. I'm asking about load. Don't confuse.
Positive to negative.
Positive to negative.
Try to see at load, current is coming like this. No, that means this terminal becomes plus or minus, ma?
Plus.
Plus.
Very good, ma. And what of this terminal?
Minus.
Don't confuse. If you see at load, at a positive terminal, current is entering. At a minus, it is leaving. Whereas if you see source, at a negative, it is entering. At a plus, it is leaving. Okay, don't confuse with that source and load. Okay. Now that means you mean to say that it's nothing but plus and it's nothing but minus. Okay. Load voltage means V2. Now tell me what is the relation between E2 and V2 in secondary side. Please tell me. Let me conclude last point. Please conclude. What is the relation between E2 and V2? I'm asking. Tell me. Relation between E2 and V2. I'm asking. Very simple question. I'm asking. Tell me.
V2 is equal to E2, sir.
E2 bar equal to what, ma? V2 bar. I'm expecting one question from you guys. Tell me who is that person going to ask my question. Anybody? Are you getting any doubt in this session? I'm just giving hint also. Just try to see this box.
Magnetizing current.
Try to see this box and try to see this box. I'm expecting one question from you guys. Please try to see this box and try to see this box and tell me. I'm expecting one question from you. Please, what is that question? Some people will think that, sir, do you want me to place minus symbol here also? No. Here. What is the reason why you should not keep minus symbol here? Everybody, anybody? Tell me more. Why I should not keep minus symbol here? Please respond. Why I should
Because
not keep minus symbol in secondary side equation?
the current direction is also same to the load.
It's not like that. How many? Tell me in the primary side, how many sources are there? V1 is the one source, and E1 is the second source. Two sources are there. And how many currents are there for you? I mu, Ix2 currents are there. So according to Lenz's law, this Ix is opposing I mu, no? To show that opposition, I'm just showing minus symbol here. But tell me in secondary side, how many sources you are having here? I'm asking how many sources you are having in secondary side?
One.
One only, E2 only. Don't confuse by seeing this V2. It's V2 is not source voltage, it's load voltage, guys. Are you getting what I'm saying?
Yes, sir.
So no. So I'm having only one source. E2 is the only source. Tell me what is the current I2 because of which source you are getting this I2 current? I'm using same color at least by seeing this color and tell me I2 is because of which source? I2 is because of which source? E2 or V2 or?
E2, sir.
E2. Okay, E2. Do we have any current because of this load voltage V2?
No, sir.
No. Do we have any current because of this load voltage V2? No. I don't have any current because of this load voltage V2, and that current is not at all opposing your I2. First of all, current is not there. Then how can it oppose I2? There is no opposition concept here, because here in secondary side I'm having one source and one load, but in primary side I'm having two sources, right? Two sources in the sense V1 is already source, and I'm just taking primary winding voltage as a source. So this Ix is opposing I mu. To show that opposition only, I'm just indicating this minus symbol. Whereas in secondary side, I'm having only one source. What is the source mass? I'm just taking secondary winding voltage as the source voltage. Don't treat this V2 as source, because we don't have any current because of this V2 voltage. So there is no current which is opposing your I2. So that's why simply I can write a E2 bar equals to V2 bar only. There is no need to write E2 bar equals to minus V2 bar. Is it clear, everybody? Please respond. Please respond. Is it clear, everybody?
Yes,
This
sir.
equation?
Yes, sir.
Yes, sir.
Equation and this equation, ma? Okay, very good. And I'll ask one question, guys. Let me conclude here. Suppose those who really understood how I wrote V1 bar equals to minus E1 bar in primary side, how I wrote E2 bar equals to V2 bar in secondary side, well and good. If you really understood, well and good, guys. If you are not understanding also, no problem, because V1 bar equals to minus E1 bar means, tell me what is the angle between V1 bar and E1 bar? Common sense. V1 bar equals to minus E1 bar means, what is the angle between V1 bar and E1 bar here?
180 degree.
180 degrees. So I am just going to show once again, if by using waveforms, there I'll be showing V1 bar equals to minus E1 bar, E2 bar equals to V2 bar. This I'll be explaining in a different method also. Nothing, by using waveforms I'll explain. That will be somewhat very easy for you. Though it is not understandable, I mean, though this topic is not understood by you, no problem. This will be understood clearly by explaining by using waveforms. Okay, but you should understand this flux lines. I mean, direction of current, direction of flux lines, all those things. How pi x is opposing pi, how pi 2 is opposing pi, and how current direction is entering at the back end, how current is entering at the front end. For direction of current entering at the front end, what might be the direction of flux? If current is entering at the back end, what might be the direction of flux? All those things you should know, because if you know all those things, subject become very easy for you. Okay, guys. Can I? I'll give. I mean, 1 minute in this discussion. Please, whatever the doubts you are having, you can ask me. I'll give time. 1 minute, I'll give. No problem. In this 1 minute, I'll be waiting for you. I'm waiting for your questions. If you are not at all asking, I'll think that you understood. I'll go for next topic. Yes. I'll ask name by name, one by one, okay? Because it's very important topic. That's why I need to ask. Please, let me see participants. I think I am just coming from bottom to top. Vidyavani. Vidyavani, is it understand, ma? Shubha? Shubha?
Understood, sir.
Rahul?
Yes, I got it, sir.
Vignesh?
Yes, sir.
Muthu Krishnan?
Got it, sir.
No problem. If you are having doubt, I'll explain once again. I'm having that much patience. Okay, please explain once. Please let me know. I'll explain once again. No problem. Okay. Muthu Krishnan said okay. Next, ma. What about Bhunesh, guys? Bhunesh?
Got it, sir.
Harish? I think you came late, Harish. Harish came, huh?
Yes, sir.
Okay, okay. Ramesh? Hari Ramesh?
Yes, sir.
Gopinath?
Sir,
Amma, tell me, ma.
sir, why we are putting E2 bar, V2 bar, the bar that
That is
means?
vector, ma. Vector. It's a vector,
Okay,
actually. It's
okay,
a vector.
sir.
Next.
Sir,
Next. Ma, please, ma.
sir,
Please, ma.
sir,
Please,
it's audible, sir.
Audible. Please, you can ask.
Sir, from the current only we are getting the flux now, sir.
Very good. Current only, after current only flux will come.
But in the secondary, you first put that flux direction and only then you choose that current direction.
It's not like that. Just listen. Actually, our electrical machine subject, if you observe clearly, first of all, voltage, let me write here. Generally, you'll be having first voltage, then current. Wait. Then current generally, because of current flux, because of flux. So actually, first voltage. If there is closure path, current. Then because of current, you'll get flux. Once again, because of flux, you'll get voltage. Or because of voltage, you'll get current. Okay, this is a cycle path. No. Now your question in the secondary side, you are saying that. First of all, let me go step by step. First, V1 is the voltage source connected in primary side. Okay, V1 is the voltage connected primary side. I'm just writing here. V1 is the voltage source. Next, current taken by the primary winding is I mu. Flux produced in transformer core is I mu. Sorry, pi. And tell me, from this, you can ask doubt, ma. You can ask doubt. Tell me, because of pi, you are getting EMF induced in primary winding, nothing but E1 that I already showed here. Now you are asking doubt in secondary side, right? Secondary side or primary
Yes,
side?
secondary side.
It. Because of this pi will come and link with the secondary winding. You'll get some EMF E2. Okay. And because of this E2, if there is closed path, yes, closed path is there here because load is there. No, I connect load, so obviously I provide closure path. So because of this E2, you'll get current what?
I2.
I2, very good. Because of this I2, what you'll get, ma? Flux?
Pi2.
Because I2 is flowing in winding, no? It is I2 is current is flowing, it is coming like this, it's going in winding, no? So obviously you'll get some flux pi2. That flux only, I'm saying it is opposing your pi. And now you can ask your doubts. If you understood, okay. If you're having doubt, you can ask me now, please, ma.
So first current is the thing coming, sir.
Which current?
I2.
Which current?
I2.
I2, how it is coming? Because of E2.
Yes, sir. How you predict the direction of I2, sir?
I2, that's what I'm,
yes,
very good. That's what I'm saying. Actually, to be frank, first of all, I2 direction should be shown, then only pi2 direction should be shown.
Yes.
That is a perfect way. I can understand. First of all, I2, then only I can show pi2. But suppose if I show you I2, it is not understood. It will not be understood by you. But Lenz law, what it is saying? Effect opposes cause. That means what is our cause here? Pi is our cause. What is our effect here? Pi2 is our effect. No. Yes, no, ma. Pi2 is effect. So first of all, I am just showing pi2. Actually, it should not be. Actually, it should not. So we should not show pi2 first before showing I2. Is it clear? But what I'm saying is, so Lenz, according to Lenz law, simply we can show pi2 opposing pi. So by using the statement, pi2 is opposing pi. No. So simply here pi is yellow mark downwards and pi2 will be upwards. So I got pi2 direction upwards. So if it is upwards, no, if it is pi2 is upwards, if I want pi2 direction should be upwards, means tell me what might be the direction of I2. I am seeing pi2, then I'm deciding I2 here. So use this figure, use this image, second image. Okay. So pi2 is upwards. This I can say this one, this arrow mark. Okay, upward. This thumb indicates direction of pi2. Now tell me what about I2 current? You have to hold your core in this manner. So in this manner means what? Current is entering at back end or front end?
Backend, sir.
Backend. Which one is backend? Here is backend, no?
Yes, sir.
Backend. So it is entering here, entering, and it is leaving here, entering, leaving is the completing path like this. But as you said, first of all, I have to show I2, then I have to show pi2. That is only correct only. But if I show you directly I2, you'll be having some confusion. So like this also I can show. First of all, I can show pi2 direction, which is opposing pi. Depending by seeing this direction of pi2, by seeing direction of thumb, I can decide direction of your wrapped fingers. Like by direction of a current is entering at a back end. So like that I can decide, no problem. Okay. Is it clear, everybody? Understood, Aman? Not understood?
Okay, sir.
Simple. I think your doubt is, sir, first of all, I2 is coming, no, sir. Then pi2 is coming. Why you are showing pi2 only initially? That like that you are asking. Further, what I am saying is,
Yes,
according to Lenz's law, pi2 is opposing pi. So whenever pi direction I know, simply I can show pi2 direction. By seeing pi2, now I'm deciding I2. That's it.
Okay, sir.
Okay, right.
Okay.
Now, is there any doubts? Please, everybody, anybody? You should respond. You should respond. It is small doubt or big one. Doubt is there is no small doubt, big doubt. Okay. Doubt is doubt only, not small, not big. Okay. So please, if you are having doubts, you can ask me. Gopinath, Harish, Aarti, Hari
Sir.
Ramesh, Bonej.
Sir,
Tell me, ma.
what about this 5x, sir? It won't
5x.
interfere.
Tell me, 5x.
It won't interfere with secondary, sir.
Actually, to be frank, it will coming in interface. It link with your secondary also. That is different case, ma. That is I'll discuss. Actually, transformer as constant flux division topic is there. There I'll explain. Okay. Just I'm focusing only V1 bar equals minus E1 bar equation and E2 bar equals V2 bar. No doubt, as you said,
Yes, sir.
pi x will come and link with your secondary winding also. About that, we'll discuss in transformer as constant flux device topic. Okay.
Okay,
Please.
sir.
Next, any doubts? I actually my feeling is you are having doubts, but you are hesitating to ask doubts. Like that, I'm feeling. Is it correct? Nirmala, Rahul, Vignesh, Shubha.
Sir.
Ama, tell me, ma.
Sir, because of I, both E1 and E2 will be produced, sir.
No doubt. Yes,
Yes, sir.
obviously.
Okay,
That's why
sir.
I'm calling it as a core flux.
Okay,
I'm
sir.
not giving that flux as a primary winding flux, secondary winding flux. It's a core flux. It links
Okay,
with both. I mean, corresponding to core flux only, you are getting EMF E1 and EMF E2. Okay.
Okay,
Next.
sir.
Next. Shubha, Vidyavani, you are not at all responding, please, ma. Vidyavani. Shubha. Vignesh.
No doubt, sir.
Okay, ma. Okay. Next, Mohan Priya.
Yes, sir. Now only I asked, sir.
Gopinath, ma. Gopinath.
Yes, sir. No doubt, sir. Correct.
No doubt. Yogeshwaran.
No doubt, sir.
Okay, ma. Thank you. Thank you very much. And can I go for next topic?
Yes, sir.
Yes, sir.
Yes, sir.
Actually, suppose though see generally some people, some faculty for explain this V1 bar equals to minus E1 bar and E2 bar equals to V2 bar, they'll approach waveform point of view. They'll approach. That's very easy. I can understand that. I'll be taking that topic also. But why I'm explaining this topic also means you should know what's happening internally. Means how current is entering, how flux is opposing, one flux is opposing another flux. So all those things you should know clearly. Okay, then only it will be easy for us. Okay, right. Okay. Now, can I ask? I'll ask one question, guys. This question will be useful for us in coming sessions. Okay. Okay, everybody. Okay, very good. Just let me ask one question. Guys, can you please tell me here in this case? One minute. Let me erase some portion. I'm expecting this question from you because I observed so many people are doing wrong for one question. 2008, I think so. 2008, one question is there. 2008 or something. I'll try to show that question also. So that question, so many people are doing wrong. So I hope you will do in a right way only. But let me check. Whether you are correctly doing or not. Okay. So tell me what is the relation? What is the relation for E2 here? E2 formula in terms of N2 and pi. Anybody? Are you getting my question? So E2 proportional to what? D by dt of what, ma? N2 into pi. Clear? Very good. Next, E2 is equals to N2 into d pi by dt is there. Okay. I think you know these equations. Okay. Already. Anyway, we'll discuss. I think to be frank, this E2 can be called as, what is the name you can give for this E2, please? What is the name you can give for this E2, please? Please respond. What is the
Induced.
name you can give for this E2? I'm asking. What happened, guys? I'm asking
Secondary
name only. Huh?
Secondary induced EMF.
Secondary EMF.
Then why you are thinking? Okay, so secondary EMF. Okay, secondary EMF. I can give one more name also. Mutual induced EMF. That I will discuss in the next video. Only we are having a self-induced EMF. I hope it is there. See, self-induced EMF, mutual induced EMF. All those things are there. Okay, but before that, let me ask a simple question here, guys. E2 equals to N2 into d by dt is a relation. So is this relation is correct, or you want me to add something? You want me to add something here, or is this relation is correct? Tell me. Sorry. Is this relation is correct, or you want me to add something here? Tell me. Expecting answer from you guys. Is this relation is correct or not? I'm asking here. Simple question I'm asking. Okay. So guys, in this discussion, let me take E2 as effect. E2 as effect. Let me take pi as cos. Pi as cos. Effect opposes changes in cos. D by dt of pi. Effect opposes changes in cos. Okay. That means if you want to show that Lenz's law, I think you need to add something here. What is that?
Negative sign.
Negatives.
Please respond, everybody. Yes, respond, ma. Negative sign, right?
Yes, sir.
So negative sign. Negative sign. Okay. So E2 equals to minus N2 d pi by dt is a relation. Okay. And you already still now I discussed we are getting plus symbol here, minus symbol here. Okay, guys. Suppose my question is, suppose in the question itself, he has given you, if he has given you like this, okay, here minus he kept a plus. Okay, he is asking to find E2 value. So tell me what equation you will write. Same question he has given here. Let us assume that. Okay, generally for this sense of finding front end, back end, it should be, it should be plus, it should be minus, like that we are justifying, right? We are getting. But he said that he has given you minus symbol here and he has given you plus symbol here. Okay, so now tell me at that time, what is the formula you are going to write E2? I think there is nothing to think. It's very simple question I'm asking. Please tell me.
Plus
Guys,
N2 d phi dt.
I see, a very simple question. No? Example, if it is a P terminal, if it is a Q terminal, plus minus means EPQ means this one. EPQ means what here? Minus N2 d pi by dt. So no. Suppose I'm asking if it is plus, if it is minus here, what is he asking? EQP is asking. So no, ma? EQP is asking.
Yes,
EQP
sir.
means what I can say minus EPQ, no? So at that time, what might be the equation? What might be the formula? N2 into d pi by dt. Are you getting my question?
Yes, sir.
Yes or no? Okay, guys. That means whatever the question he has given, please try to see that question first of all. Try to see that question and try to decide polarities from your side and try to see the polarity what he has given. If he has given rightly, no problem. You can use this minus N to d pi by dt. That is okay. If he has given wrong polarity like this, please try to remove this minus. That means minus E to no. That is minus of minus N to d pi by dt. You will get N to d pi by dt only. Is there anything not to understand? Is it clear, everybody? Hello.
Yes, sir.
Suppose what I'm say, very simple question I'm asking. If you whatever the question he has given, just try to approach in your own way and decide polarities. You'll get polarities, right? Like red color plus, red color minus. We decided only. Suppose try to see the polarities what he has given. If those polarities are correct, just go for minus N to d pi by dt. Otherwise, please try to interchange the, try to make whatever the question is asking. Suppose if he is asking EQP, nothing but minus EPQ. So minus of minus N to d pi by dt, it becomes N to d pi by dt. That's it. So I'll give one question. I hope you are going to give answer for this question. Please tell me answer to this question, everybody. Are you able to see this question, ma? Everybody? Are you able
Sir.
to see question, please?
Yes, sir.
Everybody? Everybody? Now.
Yes,
Sir,
sir.
yes, sir.
So this is the question asked in a GATE 2008 for 2 marks. Okay. Now please try to tell the answer. Okay. Try to respond. So can I give time, or you want me to explain? Can I give time to you to solve, or can I explain? You won't give reply also. Huh? Very good. That means you asked me to do. That's it. Indirectly you are asking me to do. Okay, no problem. Let us see.
So
So you can give
E
time,
equal
sir.
to
I'll give time. Huh? Okay.
yes.
I'll be giving. I won't give more time. I'll be giving only 2 minutes. Please make it fast.
Yes, sir.
Yeah, please. So I'll show. This is not only the question. And if you see, next options are there. Here A, B, C the options are there. So these are the waveforms he's asking. So first of all, you please find out ERS value. Nothing but secondary EMF you have to find out across R and S. He said plus if you keep here, minus he is keeping here. He's calling it as ERS. You please find out from your side, and after that you can see options. I'll give 2 minutes, ma. Make it fast. Formula also I told you. So in this question is asking the induced EMF ERS in the secondary winding, like that is asking minus N2 d pi by d2. That is the formula. Now you can do. Minus N2 d pi by dt is the formula generally. First of all, let us check whether this polarities, given polarities are correct or not.
Correct, sir.
Correct, sir.
Let us see. Let us see. Let's see. Wait. What's the, I mean, now let me show you. Can I show you options? Option. Answer please. A, B, C, D. Which one? Which one is the right option?
B, sir.
Good, ma. Very good.
Option A, sir.
Option A you are getting. Let us see. Okay, can I solve?
And yes, sir.
Yeah. Let us see.
Yes.
See, guys, very simple. First of all, if you stop writing, I'll explain. Everybody, can I explain?
Yes,
Yes, sir.
sir.
Let us see. First of all, is EPQ is nothing but what I can say, primary individual voltage, or okay, for time being, let us assume that this is only source voltage also. Okay. So here I mu is the current entered first of all. So this direction of current entering, it is leaving at backside, entering, leaving at backside, entering, leaving at backside, entering, leaving at backside, entering, and leaving at back end. Okay, because let me first of all, guys, let me do one thing. Let me write. Excuse me. Let me write end cells also. What about this end, ma? Front end, right? What about this end? back end. What about this end? Front end.
Front
What
end.
about this end?
Back end.
Back end. Okay. And tell me what about this one? What is the other name for? I mean, I can assume front end as which one?
Beginning.
Beginning.
1 minute. Let me connect the charge. Sorry, what you said? So please. Front end is taken as which one, ma? Front end is taken as which end? In my discussion, I'm saying. Okay. Please.
Beginning, sir.
Beginning. So front end is nothing but beginning end. Front end, beginning end. Okay. Back end, ending end. Back end, ending end. Okay, guys. Now IME's current is entering here, and generally, you know, guys, we'll assume dot always at the beginning end or ending end. It's our wish. It's our wish. Okay. See, let us assume that in this figure, he assumed dot at the beginning end of coil. EPQ coil, PQ coil, and he assumed a dot at the beginning end once again at RS coil also. Is it clear, everybody? Up to this, is there any doubt? Any doubt up to this? Please, ma, respond.
No, sir.
No,
Right.
sir.
So direction of flux will be what? So if current is entering like this, so by using right hand thumb rule, so I think you have to use image number 1.
Yes,
So
sir. Top
direction of flux will be upwards,
upwards.
like this. Okay, like this. Right. So flux will be downward. Here flux direction will be downwards. Okay. Now here EMF will be induced. Same flux coming and linking with your secondary winding also. Here EMF will be induced here. Now my question is, if there is closed path, let us assume that closed path is there. Okay. Okay. Let us assume the closed path is there, and please tell me, if there is closed path, you'll get some current. Let us assume that ERS is the voltage induced. Because of ERS, you'll get some current IRS or I2. Because of I2, you'll get some current of pi 2. So you'll get some flux of pi 2. Okay. So that pi 2 is opposing which flux, ma? Let me use different color. So ERS I2 is the current. Because of I2, you'll get some flux of pi 2. According to Lenz's law, you already know, because of core flux pi only, you are getting this ERS value. Tell me, what is the flux? Who is responsible for getting this ERS value? Because of core flux, you are getting EPQ. And same flux going and linking with the secondary winding, you are getting EMF ERS also. Because of ERS, you are getting current I2. Because of I2, you are getting a pi 2. There is closed path. Let us assume the closed path is there. Okay. And tell me, this pi 2 is opposing. I'll connect load also, guys, because in my discussion, let me keep load also, because if I show current, some people will think, sir, how can current is coming if there is no load? Let us assume that load is there here. Load is there. Okay, load is there. Now tell me, yes, pi 2 is opposing pi, no? Yes or no? Pi 2 is opposing pi. So please tell me, opposing pi means what? It should be upwards or downwards, sir? Tell me answer, please.
Upwards.
Upwards.
Upwards, sir.
Upwards. Okay, upwards. Now, if I want pi 2 upwards, in what direction your I2 might have entered? Once again, figure image number 1 or image number 2. If I can show you that figures images also, please. Tell me, you have to use first image, second image.
Second image.
Tell me, pi 2 upwards. No, pi 2 upwards means, tell me, you have to use which one I'm saying. Don't see. You may think some people are getting one doubt, sir. This one also upwards, sir. This one also upwards, sir. Like that you are thinking. No, yes or no? Is it doubt you are getting? Hello.
Yes.
Is it doubt you are getting?
No, sir.
Because very simple. See, if core is this side, primary side, you are holding core like this. If core is this side, you have to hold core like this. That's it. Very simple logic here. Please try to practice. You can understand. So you have to hold core in this manner. Okay. Hello. I think you people are having some confusion. You either have to use figure number 1 or figure number 2. Is there any confusion or is it clear for you?
Yes, sir.
Clear? So tell me, figure number 1 or figure number 2? Which one I have to use?
2, sir.
Winding is it is left side, right? In the secondary side, if a primary side means winding is right side, that means you are holding core like this. In this case, your winding is left. You are here. See, you are here. In primary sense, you are here. That means your winding is at the right side of you. That's why you are holding in this manner. If you are here, and the winding you are able to see at the left side is there. I mean, tell me, how can you hold your core for having direction of flux upwards? It should be like this only, no? Try to see try to see your winding from here. Okay, from here you are here and you are seeing your winding. Tell me now how you have to hold your core, like figure number 1, like figure number 2, for having a direction of flux upwards. Figure number 1 or figure number 2? Please respond, everybody.
2, sir.
2,
2
sir.
only,
2,
2
sir.
only. There is nothing to confuse. Now tell me, 2 means it is entering at back end or front end? Tell
Back
me.
ends.
Back end. Now tell me, back end means, so I2 is entering at back end, it is entering at back end, leaving at front 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 end. Yes, like this. Okay. And yes, our current always flows from plus to minus at load, that everybody knows that. And I already told you, if you take this one as a source, if you take this one as a source, current is going from bottom to top or top to bottom. See, this one I'm saying
Bottom to top.
bottom to top,
Bottom to
no.
top, sir.
But that means here you should that means if you take this one as a source, if you take ERS as a source here, if you take ERS as a source, I mean ERS, if you can take it ERS as a voltage source, ERS. So it is entering at the bottom, no? It is entering bottom. This total winding is taken as source here. So it is leaving here. So what about the top terminal and what about bottom terminal, guys? It is plus, it's minus. So it is plus, it is minus. Okay. So whatever the polarity you got plus minus, and whatever the polarity he has given plus minus, that is same or different? Respond, please. Same or
Yes.
different?
Same, sir.
Same. That means you have to use one formula. What is that formula? E2 is equals to general. What is the formula?
Minus
E2
n
equals to
d pi.
N2 d pi by dt. That everybody knows that. Okay. And suppose here minus symbol, why I am keeping here? To show this opposition. Your pi 2 is opposing pi. No, that I'm just showing here. Pi is here. Pi is nothing but cos here, and pi 2 is nothing but effect here. So effect opposes cos. So that's why I'm just showing here minus symbol. So E2 equals to minus N2 d pi by dt. Now tell me answer for this question. First of all, let me find out from 0 to 1 and 1 to 2 and 2 to 2.5. Okay. So here is a point 0 comma 0 is the point here. And what about this point, ma? 1 comma 0.12 is the point. 0 comma 12 is the point. And tell me what about from 0 to 1? 0 less than t less than 1 in this case. What about ERS value? I mean, what about ERS value, ma? Minus N12 how much? 200 d pi by dt. So tell me what is the d pi by dt value during this 0 to 1? Tell me please. ERS is
Minus
equals
24.
to minus 200. I'm asking d by dt value. Is x1, y1, x2, y2. What about slope formula? y2 minus y1 by x2 minus x1? No.
Yes,
So
sir.
0.12 minus y1, 0 by x2, 1 minus x1, 0. So tell me what about this value, guys? I think minus
24.
24 volts is the value from a 0 less than t less than 1. Is it clear? And tell me what about in this case? I mean 1 less than t less than 2 in this portion. Very simple. There is no change in
0.
slope. D pi by dt is equals to 0. So ERS value is how much here? 0, no?
0. Yes, sir.
What about next one? 2 less than t less than 2.5. So tell me here if you see whatever this point 2 comma 0.12 is the point here. Okay. And here 2.5 comma 0 is the point here. So you are calculating slope from here to here. So this can be taken as x1, y1 here, x2, y2 here. Please tell me if you want ERS value minus N2 means minus 200, d by dt means y2 minus y1. Means what? 0 minus 0 minus 0.12 divided by x2 minus x1. 2.5 minus x1 value how much here? 2. So
2,
tell me
sir.
this value, please. I think you get plus 48 volts. Is it correct? Any change in answer, please tell me.
Yes, sir. 48, sir.
This is the first case. This is second interval. This is third interval. So from 0 to 1, you should get minus 24 volts. From 1 to 2, it's 0 volts. From 2 to 2.5, it's nothing but plus 48 volts. So what is the right option, please? 0 to 1 minus 24, 1 to 2 0 volts, 2 to 2.5 plus 48 volts. What is the right answer? Tell me, ma.
B, sir.
Option B, sir.
Option B is the right answer. Okay. I think somebody told it A option. So A option also will be correct. When? Can you please tell me? A option also will be correct. Tell me when A option will be correct. Yes.
When the
When A
dot
option
is
will be correct.
changed.
Sorry, guys.
Dot position change.
Dot position.
Changed.
Okay.
Let me solve. Let me solve. When you will get option A, I'll tell you. Okay, I'll tell you. Is it complete this one, everybody? Is it understood, everybody? Please let
Yes,
me
sir.
know.
Yes, sir.
Yes, ma.
Yes.
Let me discuss when you'll get option A. Let me discuss when you'll get option A. Okay, here some empty space is there. So I think let me draw the figure which has given. Transformer core. I think winding is like this, no? Okay, in secondary side. Let us see. Okay. Suppose okay, 1 minute, 1 minute. So I'll see. I'll show you when you'll get this one. Guys, everybody, is it audible to you? Everybody, is it audible, ma? Everybody, is it audible?
Yes.
Right.
Sir.
So tell me, in the primary side, I think he has taken your front end, no? He has taken front end here, and he has winding is like this. Winding is like this. So this one is front end. This one is back end. If you observe clearly in our question, here he has taken front end. Did you remember that? Yes or no? Suppose instead of like this, suppose if I take like this. Now please. So now I think he has given here plus minus. What's the name he has given? EPQ. EPQ. And here how many number of turns he has given? Did you remember 100? And here how many turns he has given? 200. Flux direction he has given like this. And it's a plus minus ERS. Can you solve this question? Let me say frankly, guys, everybody, are you able to? I mean, is it audible to you, everybody? Guys, everybody, is it audible,
Yes,
everybody?
sir.
See, actually, I just changed that question. To be frank, that 2008 question really asked is that, but not like that. So question he has given like this. Let us see. Let me show you. Here he kept minus symbol. Sorry, here he kept a dot here. Okay. You tell me, guys, with your common sense, I already told you where you have to assume dots. If you assume dot at the front end in a coil A, you have to assume once again dot at the front end only, no? Yes or no? But actually in that year 2008, what he has given, let me explain. Let me explain. So what about this end, ma? This end is back end, no, guys? And what about this one, ma? Front end. Okay. So you tell me with your common sense, please. You please tell me, here it is plus minus. So regarding our knowledge, whatever we discussed, if you assume dot at the front end, tell me in secondary winding where you have to assume dot. Please tell me, everybody.
Front
Please,
end.
tell me. Front end, right? Here you have to
Front
assume.
end.
Here you have to assume. But in that year, he kept a dot instead of at front end, simply kept here. Is it clear what I am saying? Everybody, is it clear? Are you getting what I am saying, guys? Everybody.
Yes.
Now, please answer to this question. I'm asking to this, answer this question. Let me explain first of all. Let me solve this question. Actually, you should not ask like this. Suppose front end is, if he's keeping dot at a front end, he should keep dot at the front end only. So, but don't bother about accuracy of the question. Whatever he's asking, depending on the question, you have to react. So, no, sir, my sir told me like that. You had given wrong answer like that. Don't argue with those people. Okay. Suppose if he has given like this, now tell me at that time what you have to do. Very simple thing. So please let us do now. Let us do. Now tell me. I please, I'm expecting answer from you guys. After connecting voltage source, I think you'll get some current, right? What is that current? I mu. I mu. Tell me direction of current. Once again, same. I'm just repeating the question, but I'm just solving answer for this question. Okay. It is entering at front end, leaving at back end, entering at front end, leaving at back end, entering at front end, leaving at back end, entering at front end, leaving at back end. Okay. So direction of flux will be upwards or downwards, sir? Please respond. Direction of flux upwards or downwards, ma? Respond, please. Hey guys, hello.
Upwards.
Rahul, upwards or downwards, sir? Please respond, ma. Hello.
Yes, sir. Direction of
Direction of flux I'm asking. Correspond with I mu. Direction of flux I'm asking.
upwards.
Upwards, sir.
Upwards. Upwards. Okay, upwards. So upwards like this. Okay. Now tell me. So because of this core flux, we are getting EMF from primary side. Same flux will come and link with the secondary winding also. Now tell me, you are getting some EMF also, ERS. I'm just calling it as ERS value. So now I'm one more thing I'm asking. Let's suppose some load is there here. Suppose some load is connected. Let us assume some load is connected here. I told you some load is connected here. So you'll get because of this load, you'll get some current, right? So tell me that because of the ERS value, you'll get some current I2. Because of the I2, you'll get some flux of pi2, which will oppose which flux? This pi2 is opposing which flux, ma? Pi. So if pi is downwards, now pi2 will be upwards. Pi2 will be upwards. Pi2 will be upwards. Pi2 will be upwards. Now, see please. Yes. Yes, upwards like this. Okay. Now tell me, it is upwards, right? Now, if you want pi to upwards, in what direction your current might have entered? Please respond, everybody. In what direction current might have entered? At back end or front end? Please respond.
Back end, sir.
Back end. Back end is here, not here now. Now I'm just changing question. Back end is here, not there. Okay. Current I2 is here now. Okay. I2 is entering at back end, leaving at the front 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 end. Yes, current is coming like this. Yes, you know at load, current always flows from a plus to minus. So this becomes plus and this becomes a minus. So in fact, it should be minus here. It should be plus here. Yes or no, guys? Is it clear,
Yes,
everybody?
sir.
For this question, for the sense of winding, if front end is here, back end is here, back end is here, front end is here, a minus symbol, minus polarity should be here, plus polarity should be here. So at that time, I can simply write ERS formula. ERS equals to, as you said, as I said, minus N2 d pi by dt. I can write like this, no problem. But he's asking question. No, I mean minus plus means I call that EMF as a minus ERS. No. See, ERS value means here plus is here, minus is here means that he has given in the question. But I am asking for the sense of winding, you should polarity should be minus here, polarity should be plus here. So now my simple question I'm asking now, generally, please tell me what is the formula for this ERS. Generally, I'm asking for this polarity. If it is minus, if it is plus, minus N2 d by dt is the formula. But I'm asking formula for ERS, red color ERS. I'm asking formula for red color ERS. Red color ERS means this one. If polarities are like this, at the time tell me, I'm asking question. ERS is equals to what you should write? Minus N2 d by dt, minus of minus N2 d by dt.
Minus of minus.
Minus of
No,
minus.
simple, no. Suppose here actually, if it is a P, if it is a Q, I'll write EQP value means, EQP value, I'll write some formula, I'll write EPQ, some other formula will come. Okay, don't confuse. It's a very simple thing only. If polarity is minus, if we also given minus here, plus here, simply you should write minus N2 d by dt only, have to find out. But polarity is minus here, plus here, but he is giving a plus minus here. So ERS means minus of minus N2 d by dt. So at that time, your formula, your value becomes what, ma? Tell me. So it becomes N2 d by dt, N2 d by dt. So tell me at that time answer, please. So 0 less than t less than 1. So your ERS equals to N2 d by
24.
dt. I think previously you got minus 24. So minus 24, now you get one more? 24
Plus
volts, I guess.
24.
And 1 less than t less than 2, as usual, you'll get 0
0.
volts. 2 less than t less than 2.5. So what you get? ERS value?
Minus
Still
48.
plus 48 you got now, you'll get minus 48 volts. So what is the right option here?
Option A.
Option A will be right option if sense of winding is changed. Okay. But for the question what has given, for this question, no doubt, question option B is the answer. If here it is minus, if we are instead of for front end here, if it is back end here, instead of back end, if it is front end here, your answer will change. So no doubt it will be somewhat difficult for you to follow, but so questions will be asking like this only. Okay, guys, is it clear, everybody? You can
Sir, I
ask
have a
now.
doubt, sir.
You can please let me ask. Please ask. Please ask.
Sir, if the direction of flux is known, then no need to consider dots, no, sir. Like this only we can conclude.
That is also okay. Suppose some people will say that generally I'm saying procedure point of view, every time we have to go from starting to ending, because every time polarities will be given. Since polarities are given, you will say that there is no need to give minus symbols. So directly I'll go ERS equals N2 d by dt, like that you are saying, right? Yes or no?
Yes, sir.
That also okay. But generally I'm saying, guys, sometimes there are chance for doing mistake. So please try to practice for starting time you have to practice. So after some time, no, you can directly by seeing polarities, you can decide ERS whether I have to keep minus symbol or not. All those will come. But now starting onwards, no, since you are in starting condition, please try to check all those things so that your subject also will build up. Okay.
Okay, sir.
Clear, everybody?
Sir,
Okay, sir.
I have one more doubt, sir.
Please, ma'am.
Can you go to next slide, sir?
Yes.
Yes, sir. Sir, here we got that ERS equals to minus N2 d phi by dt, like positive terminal down and negative terminal upside.
He has given that one, not us. Okay. Actually, it's
Okay,
minus.
sir. Not that. We are concluding like this. From positive down, negative up. So, sir, if we are substituting values in ERS equals to minus N2 d phi by dt, then we'll get ERS as negative value.
That's what I'm saying. No, actually, in the question, instead of plus and minus, if he has given minus and plus, we don't have any problem at all.
Okay.
Because he has given right, he has given right polarities only. Definitely, you can find out this form by using this formula. You can tell the answer.
Yes,
but
sir.
if he is changing polarity, now you have to minus off that answer. You have to do. Are you getting my question, ma? So very simple logic, guys. Very simple logic. I'll ask one question. I'll make you question simple. I'll make you doubt easy. See, let us see. Suppose in this question, if he's asking you ERS, you are saying like this, no? Yes or no? Suppose if I ask you ESR, that means ERS means here plus, here minus, no? Suppose if it is plus, if it is minus, I'll ask you ESR value. How can you do that? How can you do that question?
Minus of ERS.
That's it. That one I'm doing there also. There is no need to confuse. Okay. Here plus should be here, minus should be here. And if he has given you plus here, minus here, there is no need to bother. Simply find out minus N2 d by dt. That's it. Answer. Suppose if instead of given plus minus like this, if he has given you minus plus like this, that at that time he's asking to find a voltage. That means whatever the answer you are getting, that you have to minus it. That's it. No. Why you are having confusion? I don't know. Is it clear, everybody?
Yes, sir.
No. So please try to ask. Some people are having doubt. Please, I need some confirmation from you, sir. Rahul, somebody asked one question. What is that? Who asked that question, please?
Yes, sir. Rahul, sir.
Tell me. Is it clear for you?
Yes, sir. Actually, I was asking. I was not considering that load side and all. I was simply saying that here. I'm not considering that, sir. We just got plus minus up, down plus and up minus, right? So ERS equals to minus N2 d phi by dt. So if we are
actually ERS means it's not like that. Actually, see, ERS means what you mean to say. Suppose let me do one thing. Let me know. So suppose here ERS and ESS something polarities are changing here. That's the problem here.
Yes, sir. R is down. S is up.
R is down.
S is up.
R is down. Very good. R is down. S is up. At that time, ERS means simply you can find out. How can you find out? Tell me now.
Yes, sir. If you're substituting in case say N2 value and d phi by dt value, if you're knowing it, so then the ERS value will be negative only, right? So
see, what I'm saying is generally, if he's asking R here, yes, that is okay. That is only our question he's asking, bro. Okay. At that time, R is upside, S is downside means you have to use formula ERS means, okay, minus of minus N to d by dt. This one you have to find out, okay. Suppose he has given you S here and he has given you R here. Or that if you want to find out ERS value, okay, simply you can take RS plus here, you can take SS minus, simply you can find out minus N to d by dt. Now tell me, now you can ask your doubt, okay, please tell me now. Are you getting my question? So
Yes,
please
sir.
try to see where is plus polarity, where is minus polarity, that you have to see. Anyway,
Yes, sir.
if you solve some questions, you can understand clearly. Okay, no problem. Actually, by this time only, I should not solve this question, but I thought you will understand. No problem. I'll explain once again this question. There is no need to confuse. Okay, guys, is it clear? Can I go for next slide, please?
Okay, sir.
Yes.
Please. Wait. Everybody.
Yes, sir.
Okay, ma. So now tell me, let me discuss about statically induced EMF. Okay, let me discuss about statically induced EMF. So tell me, what is the other name for? What is the type of EMF induced in a transformer? Ma? Statically or dynamically? Please respond.
Static.
Static, right? So type of EMF induced in primary winding of transformers can be called as in the static EMF also you are having two classifications. One is self-induced EMF, one is a mutual induced EMF. Are you getting what I am saying? Okay. So generally in transformer type of EMF is statically induced EMF only. There is no doubt in that. Okay. In that statically also you are having self-induced EMF is there and mutual induced EMF is there. Self-induced EMF means very simple. See, let us see. See, because suppose whenever voltage is connected to the primary winding of transformer, some current is flowing in the primary winding of transformer. So time varying flux is coming. It is linking with the primary winding. Some EMF is induced in the primary winding itself. That EMF can be called as primary induced EMF or self-induced EMF. Okay. So ultimately, tell me what is the definition I can give for this self-induced EMF? EMF induced in the primary winding due to time varying current flowing in the primary winding itself. Is it clear, everybody? Yes or no? Hello?
Yes.
What about mutual induced EMF? EMF induced in secondary winding. Tell me E2 is because of which flux ma? Pi. This pi is due to which current ma? I mu. I mu is current flowing in which winding? Primary winding, secondary winding?
Primary.
That means mutual induced EMF is nothing but EMF induced in the secondary winding due to time varying current flowing in the primary winding, whereas primary winding and secondary winding are mutually coupled through transformer core. Okay, so indirectly self-induced EMF nothing but primary induced EMF, mutual induced EMF nothing but secondary EMF. That is the only thing I want to say. Very simple things only. Please let me show you. Yes. So statically EMF. So on that one, you can say self-induced EMF is there, E self, or one more name, primary induced EMF, or I can say E1. Okay, guys. Mutual induced EMF for E mutual, or I can say secondary induced EMF for E2. Okay, guys. Now I already given definition for self-induced EMF. What is that, ma? Please try to respond. Yogeshwar, are you there?
Yes, sir.
Self-induced EMF. EMF induced in the primary winding due to time varying current flowing in the primary winding itself. That's it. You know why is E self proportional to d by dt of n1 into pi? No. E self equals to n1 d by dt. Tell me why I'm just keeping minus symbol here. Anybody, please, everybody give answer. Why I'm keeping minus symbol here? Please tell me.
Lens law.
Lens law. I mean, I can take pi as cos here. I can take effect as E self here. No, effect opposes cos. So that's why I'm just because of Lenz law, I'm just keeping that minus symbol there. Minus n1 d by dt. So E self equals to, see, I'm doing one thing, minus d by dt. I'm just multiplying numerator denominator with the di. So now after multiplying with the di, simply guys, just try to see this one. Minus n1 d pi by di I'm writing at one place, and di by dt I'm writing at another place. See, di by dt I'm writing one place, remaining portion minus n1 d pi by di I'm writing in another place. Okay, so E self equals to minus d by di of, I'm just taking n1 inside, n1 into pi into di by dt. We know, guys, generally voltage across inductor, if you take because transformer primary winding nothing but inductance nature only, no. E self equals to what? Minus L self di by dt. You please compare equation number 1, equation number 2. So minus di by dt, and here L self is there, no? L in place of L self, what is there, guys? Here, respond please. In place of L self, what is there? D by di of n1 into pi is there, no? Yes. L self equals to d by d of n1 into pi. That means self inductance means you might have learned in network theory. L equals to n pi by pi. N pi by I means flux linkage by current. Okay, that one I'm writing here. Self-inductance is defined as rate of change of flux linkage. N1 into pi means what, guys? Flux linkage. Rate of change of flux linkage in which winding? What is the number of turns I have taken here? Respond, please.
N1.
N1. Rate of change of flux linkage in which winding? Primary
Winding.
Due to time varying current. Which type of current flowing in primary winding? Time varying current, do you know?
Yes, sir.
Due to time varying current flowing in a primary winding itself. Okay. And guys, what is the previous question he has given means very simple question he has given. E self is equals to formula generally you know minus n1 d pi by dt, you know, that is okay. If I write minus d by dt of n1, if I take inside n1 into pi, it becomes. So n pi is nothing but flux linkage. Flux linkage can be shown with this symbol, size symbol. Okay. So ultimately E self, because what is the formula, guys? Tell me. Minus d psi by dt. So in 1 year, he asked one question. So he has given this equation, and this equation is a summation of which two laws, like that he asked one question. So tell me, in this equation, you are able to see two laws, Faraday's law and Lenz's law. Yes or no? Tell me.
Yes, sir.
Minus symbol is because of Lenz's law, and the rate of change of flux linkage, if it is there, EMF will be induced. That is because of Faraday's law only, no?
Yes.
Sir, no, that means,
Yes.
so if you see this equation, it is a summation of Faraday's law and Lenz's law. So directly ask this question. Let me show you that question also. See, laws of electromagnetic induction. Let me show. Yes, laws of electromagnetic induction, Faraday's law and Lenz's law are summarized in the following equation. It was asked in GATE 1998 for 1 mark. Okay, E equal to IR, E equal to L dA by dt, E equal to minus d psi by dt.
Option
What is the
3.
right answer, please? Minus
D psi by dt.
d psi by dt is the right answer. Okay, simple question. Okay, next. So I think I explained about self-induced EMF and self-inductance. Let me go for mutual induced EMF. So tell me, guys, what is the definition for mutual induced EMF? I'm just giving definition for mutual induced EMF. E mutual. Tell me, please. EMF induced in the secondary winding due to time varying current flowing in which winding? Primary winding due to time varying current flowing in primary winding. Where primary winding and secondary winding they are mutually coupled. No, that also you need to write. EMF into secondary winding due to time varying current flowing in primary winding, primary winding and secondary winding are are magnetically coupled with each other. Magnetically coupled with each other with each other. So now please tell me, please complete this portion. E2 equal to, or I can say E mutual, whatever you can write anyway, no problem. Okay, otherwise I'll write a E mutual or E2, whatever. So see here, E mutual induced means E mutual I can write, or I can say E2 also I can write, no problem. Okay, E mutual is equals to, or E2 is equals to d by dt of what, you should tell here. I'll write N2 into pi. So E2 equals to minus N2 d pi by dt. That implies E2 equals to what? Minus N2 d pi by dt. I just multiply with the di. Okay. So here minus N2. Okay, here d pi by di I'll write as d pi by di only. Next di by dt I'm just writing here. So at that time E2 equals to what? Minus d by di of, I'm just taking N2 inside. N2 into pi into di by dt. So we know E mutual or E2. E mutual or E2 is equals to what, minus mutual inductance M into di by dt. Okay, from 1 and 2, mutual inductance M equals to what, simply write, simply just try to equate this one. D by di of N2 into pi. Okay, d by di of N2 into pi. So formula for this M defined as rate of change of flux linkage in which winding? Primary or secondary? Secondary winding due to time varying current flowing in which winding? Primary winding. And you know, primary winding and secondary winding are, are magnetically coupled or magnetically coupled with each other. Is it clear, guys? Everybody? So note once again, E mutual or E2. You can write E mutual or E2 equal to what? Minus N2 d pi by dt. Minus d by dt of, I'll take N2 inside. So minus d psi by dt. So summarization of which, Faraday's law and Lenz's law. A simple thing only. Is it understood for you, everybody?
Yes.
Is it understood or not? Yes or no? Please tell me. Please respond, guys. Everybody.
Yes.
Yes, sir.
Respond. Okay. Mohan Priya, is
Yes,
it
sir.
clear?
Yes, sir.
Gopinath. Very simple. There is no need to
Yes,
think.
sir.
Tell me without seeing screen. Please tell me what is the formula for E2 in terms of N2 and pi t. E2 equals to minus N2 d pi by dt. That's it. E1 equals to minus N1 d pi by dt. That's it. So E equals to minus N d pi by dt means it's a summarization of which two laws? Respond, please.
Faraday's and Lenz's
Faraday's
Faraday's
Law
law
and
and
Lenz's law.
Lenz's law.
Lenz's law. That's it. That's it. Okay. Next, this is about statical EMF, self-induced EMF, and mutual induced EMF. Okay. And let me explain EMF equation. After that, we'll stop. Yeah. Let us see. EMF equation. Very important topic once again. So, guys, let us see. Let us see. Okay. So, guys, you know which type of source voltage, which type of supply you are giving to the transformer? Respond, please. Time varying, time invariant, amma. Respond, amma. Huh?
Time variant.
Time variant. Whenever source is time variant, current taken the transformer. Respond, please. Respond, please.
Time variant, sir.
Time variant.
Time variant.
What is the flux produced in
Time
transformer
variance.
core?
Time variant.
Time
Like
variant.
this, pi. Can I take pi equal to pi m sin omega t? Yes or no?
Yes, sir.
Yes, sir.
Next, because whenever flux is time variant, what about EMF? It is a primary winding. Do you have rate of change of flux linkage? E1 proportional to d by dt of n1 into pi. Is it possible? Not possible.
Possible, sir.
Possible. E1 equals to minus n1 d by dt. Why I'm writing minus symbol here? Please respond.
Lenz's law.
Lenz's law.
Because of Lenz law. Because of Lenz law. Because of Lenz law. So E1 equals to minus n1 d by dt of pi means what? I had taken pi m sin omega t. So it's a simple mathematical portion only. Minus n1. I'm just taken pi m outside. Derivative of sin omega t cos omega t into omega. E1 equals to minus n1 pi m. I taken this omega here. Minus n1 pi m omega into cos omega t. E1 equals to, please try to see here, n1 pi m omega minus cos omega t can be written as sin of omega t minus 90. Is it clear, everybody? Yes or no?
Yes, sir.
Yes, sir.
Try to see this pi equal to, let pi equal to pi m sin omega t, no? And what about even sin of omega t minus 90? That means what is the indication? E1 lags flux by how much angle? Please tell.
90.
90
This sin
degree.
omega t is sin of omega t minus 90. Tell me.
90 degree.
Very good. That means I can write here E1 lags flux by how much angle, ma? 90 degrees. It is because of which law? How you are getting this one? How you are getting E1 lags flux by 90 degrees? Suppose, guys, instead of taking, if you won't take minus symbol, here you will get sin of omega t plus 90 you will get here. Are you getting what I am saying? Hello?
Yes, sir.
Hello? If you won't take minus symbol here, in this equation, you get sin of omega t plus 90. That means sin of omega t minus 90 I'm getting means it is because of which one? Minus symbol. This minus symbol is due to what? Lenz law. That means sin of omega t minus symbol is there. That's why I'm writing E1 lags flux. Plus means what here? You will write E1 leads, no? Here minus symbol is there. E1 lags flux by 90 degrees. So why minus symbol is coming means because of this minus symbol. This minus symbol is due to Lenz law. So ultimately, because of Lenz law only, I can write E1 lags flux by 90 degrees. That's the conclusion. Is there any doubt till now? Please, I need questions from you guys.
Yes,
Is it
sir.
clear? Is it clear, everybody?
Yes, sir.
Mohan Priya, Rahul, Nirmala, Gopinath, Harish,
Clear, sir.
Vignesh,
Clear,
Subha,
sir.
Vidyavani, okay, yeah?
Yes,
So
sir.
tell me
Yes,
why
sir.
Yes,
why
sir, yes.
E1 lags flux by 90 degrees? Why E1 lags flux by 90 degrees? Because of which one?
Lenz's law.
Lenz's law.
Because of Lenz law. Okay, very good. Next, similar. So guys, try to listen one important point, guys. Here, it's very important now. Here, let us see. Yeah. Now, please try to see. So, if you see this equation, okay. I think I wrote here already. Pi equal to pi m sin omega t. Here, equation number 2. From 1 and 2, I wrote E1 lags flux by 90 degrees because of Lenz law. That is okay. And try to see this equation number 2, guys. If you want RMS value, you know RMS value means what here? Maximum value by root 2, no? That everybody knows that, right? RMS
sir.
value means, maximum value by root 2. Is it clear, everybody?
Yes, sir.
Yes.
Understood? If you want E1 RMS, E1 max by root 2. So this box is in this box is in this form. E1 equals to E1 max sine of omega t minus 90, like this it is there. So okay, so if you want E1 RMS value, E1 max by root 2 you have to do. So E1 max value how much? N1 pi m omega by root 2. So omega value how much here? 2 pi f. If you calculate this, you are going to have E1 RMS value 4.44 N1 pi m into f. Is it clear, everybody? Yes or no? Respond, please.
Yes, sir.
Yes, sir.
This derivation is not necessary for you. Those who are preparing for TNEB, TREB, even for GATE people also, derivation is not necessary for us. But I'll tell you what are the points you have to remember, that I'll tell you. So similarly, if you see in secondary side also, guys, see the same manner you have to proceed. D by dt of n2 into pi, E2 equals to minus symbol. Tell me why I'm writing here. Respond, please, ma. Because of which one? Which law, ma?
Lens law.
Lens law, ma. Okay. Minus n to d by dt minus n to d by dt of pi means pi m sin omega t. Same thing you have to do. So ultimately, just like equation number 2, equation number 4, you'll get like this. E2 equals to n2 pi m omega sin of omega t minus 90. Tell me, guys, one you know pi m sin omega t. You are getting 2. Equation number 4, you are getting sin of omega t minus 90 means what? What is the relation if you compare equation number 1 and 4, guys? So pi equal to pi m sin omega t, and if you see equation number 4, E2 equals to sin of omega t minus 90 you are getting. What is the conclusion? Which one is lacking? Which one?
Lakhs.
Which one is lacking? I'm asking.
E2 lakhs
E2
by
is
E2 lakhs flux by how much angle?
90 degree.
90 degrees. No. Just like E1 lakhs flux by 90 degrees, E2 also lakhs flux by 90 degrees. That's it. And if you want E2 RMS value, guys, E2 max by root 2. This is nothing but I already told you this equation is in this form. In this form, E2 is equals to, I can say E2 max sine of omega t minus 90. You are not studying academic year, so derivation not necessary for you. But I'm just telling. I'll tell you reason also why I'm just explaining this derivation. Also, I'll tell you. So E2 RMS equals to E2 max by root 2 ma. So E2 max value how much ma? N2 pi m omega by root 2. So what is the value you are getting, please? Same equation, but in place of N1, what you'll get? N2 you'll get. That's it. So you have to remember only equation number 3 and equation number 5. This derivation, all those things are not necessary for you. Is it clear, everybody? Everybody. Okay. But these observations are very, very important for competitive examinations, for GATE, for PSUs, or for whatever. Okay. Observations. So we don't see observations. I'll ask you, try to respond. After that, I'll show you slide. Okay. So tell me, guys, whatever this slide I just shown you, in that E1, E2 are which values, ma? M 4.44, N1 pi m into F, whatever the formula you got, that E1 value is which value? Average value, RMS value, or peak value? Tell me. You are having equation, main equation, E equals to 4.44 N pi F. That E1 value, similarly E2 equals to 4.44 N2 into pi F into N2 into pi m into F. Those E1, E2 are which values I'm asking? RMS values,
RMS, sir.
average
RMS,
values,
sir.
peak values.
RMS. sir.
RMS.
Respond, everybody.
RMS.
RMS. So observe, guys, this E1 RMS, E2 RMS. So E1, E2 are RMS phase values. Since we are discussing single phase transformer, here I'm taking N1, N2. Suppose if you take 3-phase transformer, guys, N1 per phase you should take. N2 per phase you should take. Then the equation becomes what? E1 RMS per phase, E2 RMS per phase. There simply N1 per phase you should take, N2 per phase you should take. That's it. So since we are discussing single phase transformer, so by default number of turns nothing but per phase only. Suppose for 3-phase transformer, if you want per phase value, number of turns should be per phase. Okay. So next question. Please don't see these observations. Honestly, try to see these equations. Equation number 3 and equation number 5. Tell me in these equations, guys, what is the flux term I used in equations? Please pronounce that flux term. Flux used in EMF equation is what? Respond, please.
Maximum flux, maximum value of
just
flux.
whatever I wrote, simply study that one. Pi m.
5 m.
Tell me now question. So you said E1, E2 RMS values. That's okay. Now I ask question. Flux used in RMS value of EMF equations is what type of flux?
Maximum value, peak value.
Very
sir.
good, very good. Because you know pi equal to pi m sin omega t initial I had taken, no, that means it will be in this manner. Okay, here plus pi m minus pi m. I already told you, yes or no? This pi m is what? Maximum value of flux or peak value of flux. So E1 comma E2 are RMS values only, but in that EMF equations, flux used is which value of flux? I mean RMS value of flux, average value of flux, or peak value of flux?
Peak value.
This is a previous question, that's why I'm asking. Please respond.
Value, sir.
In that RMS
Peak
value of
value.
EMF equations, flux used is which type of flux? RMS value of flux, average value of flux, peak value of flux.
Peak value.
Peak, sir.
So please try to see here. Flux used in E1 comma E2 equations is maximum value or peak value of flux. This is the question asked in one PSC question. One public sector units asked this question. Okay. So many people will be having confusion. Sir, E1 comma E2 RMS value, sir. Let me take pi also RMS, sir. No. Pi is not RMS value. See, pi m is there. Pi m is what? Maximum value of flux. Okay. So for that one, I just derived all this. Otherwise, not necessary. Okay. Now, guys, equation number 3, please try to see and tell me E1 by N1 value, everybody. E1 by N1 value, how much? See and tell me, ma. E1 by N1, I'm asking. 4.44 pi m into F, ma?
Pi m
Yes.
into F.
From equation 5, ma. I'm asking E2 by N2 value, please. 4.44 pi m into F,
Pi into
yes
pi
or
m
no?
by F.
That means what is the conclusion, guys? E1 by N1 equals to what? E2 by N2, no? Yes or no? That
Yes.
equal to K. K means what? Transformation ratio. Are you getting my question?
Yes.
Try to understand this relation, guys. E1 by N1 means what? What it actually suggests us, what it actually tells us. Suppose in primary side, example 1 turn, 2 turns, 3 turns, 4 turns, 5 turns are there. Let us assume that. In the secondary side, 1 turn, 2 turn, 3 turn, 4 turn, 5 turn, 6 turn, 7 turns, 8 turns, 10 turns are there. Okay, whatever, and so on, 8, 9, 10, and so on. Okay. I'm asking a question here. E1 by N1 equals to E2 by N2 means what, ma? E1 by N1 means what? Induced EMF per turn. Suppose in primary side per turn, how much EMF is induced? In the secondary side also per turn, same amount of EMF will be induced. That's the question. That's the meaning. Are you getting my question? Respond,
Yes,
please.
sir.
Yes, sir.
Per turn, EMF induced will be same in primary as well as secondary side also. That's the meaning. Okay. Suppose if it's step up transformer, in the secondary side, the number of turns will be more, so more EMF will come. So I mean, it becomes step up transformer. Suppose for step down transformer, secondary side number of turns will be less, EMF will be less, it becomes step down transformer. That's it. It's speed depending on number of turns. Step up transformer, step down transformer, it will be varying. Okay. So, but induced EMF per turn will be same. That you have to understand. See, why I'm asking repeatedly, I'm asking this question means, guys, very simple. I'm asking, just listen carefully. Hello. Suppose they'll give you E1 by N1 value, they'll give you example, they'll give E1 by N1 value over 2 volts. They'll give you N2 turns value. Example, they'll give you 40 turns and they'll ask you to find E2 value. Are you getting what I'm saying? They won't give you E2 by N2 value. They will give you E1 by N1 value. You should know that E1 by N1 is nothing but E2 by N2 only. So E2 becomes how much in this case? Hello? Hello? Hello?
Yes, sir.
Yes, sir.
Tell me, ma. E1 by N1, he'll give you, and he'll ask you to find out E2 value. They'll give you N2 value also. So tell me, what is the value? I'm asking.
80 volts.
80 volts. So that's why you're thinking. It's a very simple question. E1 by N1, nothing but E2 by N2 only. So E2 by N2 equal to, E2 by N2 equals to 2. E2 equal to 2 into N2, 2 into 40, 80 volts. That's it. So you should know E1 by N1 and E2 by N2 same. Then you can get the answer. Okay, guys. Now let me ask one more question, guys. So tell me from this transformation ratio K means what is the formula? Tell me in terms of E and in terms of N. It means try to understand clearly. So tell me in terms of E first. In terms of E. In terms of E, I'm asking. Please respond. In terms of V, I'm asking formula for K. K
E2 by
equal to,
E1.
guys, very simple. Let me use different color so that I'm just going to ask one question here. You should respond. K value I'm asking, right? So suppose if I take E1 here, okay, if I take N2 here, at that time k equal to what, ma? E2 by E1. If I bring N2 here, it becomes N2 by N1. Yes or no? Respond, please.
Yes.
Respond. So k equal to E2 by E1 equal
Yes,
to
sir.
N2 by N1. K means transformation ratio. Okay. Okay. What about turns ratio? So I can take this one as a fifth observation. Turns ratio means let me represent this with a symbol. So primary turns N1 by secondary turns N2. Don't confuse. Transformation means N2 by N1. Turns ratio means N1 by N2. N1 by N2 means what? Indirectly, I mean 1 by K only, no? N1 by N2 means, okay, E1 by E2 equal to 1 by K. Is it clear, everybody? Yes or
Yes.
no, please respond.
Yes, sir.
Yes, sir.
Now I am just going to ask one question to you. Please respond clearly, okay? Let me take some other slide because I'll write here something. I'm okay. Anyway, I'll write here. I'm just going to erase afterwards, okay? Otherwise, I'm having space here. I'll be right. Now tell me, guys. So you said E1 by N1 is equals to E2 by N2 is equals to K, you said, right? And K equal to E2 by E1 is equals to N2 by N1, right? So, and turns ratio told, turns ratio means you said, let me use symbol A, N1 by N1 by N2, N1 by N2. Okay, guys. Suppose some people instead of taking this E1 here, are you following, everybody? Are you able to listen my voice?
Yes, sir.
Yes, ma. So I'm asking one question here. So what you did here actually simply, excuse me. Yeah, wait, ma, wait. Let me select color. Okay, I selected a yellow color. It's not visible here. Okay, no problem. Excuse me, please, ma. Wait. Okay. So E1 by N1 equals to E2 by N2 equal to K here. So I just brought E1 here, guys. I just brought N2 here. Now K equal to what you writing? E2 by E1. I just brought E1 here. N2 I taken here. N2 by N1. So some people will think like this also, sir. Why you're taking like this only, sir? K equal to, some people bring E2 here. Some people bring E2 here. Okay, that at the time, what is the formula, ma? E1 by E2. And instead of taking N2 here, some people will bring N1 here. So it becomes what? N1 by N2. Okay, are you getting what I'm saying, guys? Excuse me, are you getting what I'm saying? Hello?
Yes, sir.
Yes, sir.
That means for transformation ratio, you are getting two formulas. Are you getting two formulas? Yes or no? Tell me.
Yes, sir.
One formula, please tell me. K equal to what? E2 by E1, N2 by N1. One more formula, please.
E1 by E2,
E1 by A2, N1 by N2.
N1 by N2.
Suppose if you take first formula, so K equal to E2 by E1, N2 by N1, turns ratio becomes N1 by N2. If you take second formula, K equal to N1 by N2 means turns ratio becomes what, ma? Reverse, N2 by N1. So among this 1 and 2, tell me which one is correct, I'm asking. Among 1 and 2, which one is correct, I'm asking. Please respond. Please respond, guys. Among equation number, among first formula, second formula, which one is correct, I'm asking.
Second
Respond,
one.
please. Please
Second
respond.
one.
Respond, please.
Second one, sir.
Second one correct, huh? Why it is why first one is wrong? Everybody. Egeshwaran, Gopinath, Aarti, Mohan
Yes.
Priya, Rahul, Vignesh, Shubha, please tell me.
Sir, because it is ratio, so that's why.
Ratio what? I mean, E1 by E2 you are saying, right? Here K
Yes,
also,
sir.
E2 by E1. Are you getting my question?
Okay,
So,
sir.
to be frank, guys, two formulas are correct only. If you observe some textbooks, okay, if you observe some textbooks, in one textbook they'll be giving you first formula, in some textbook they'll be giving second formula. Both are correct only. Both are correct only. Okay. Excuse me, please wait for 1 minute, ma. Can you give me 1 minute, please? Please. Okay. 1 minute, please. Okay. Is it visible to you, everybody? Hello. Hello, Rahul. Is it visible?
Yes, sir.
Okay. So I'm asking very simple question. Transformation ratio means N2 by N1, E2 by E1. One more formula, K equal to N1 by N2, E1 by E2. Both formulas are same only. In some textbooks they'll be taking formula number 1. In some textbooks they'll be taking the formula number 2. So I'm saying two formulas are correct only, but what? But among this 1 and 2, I'm asking you to remember formula number 1, Amma. Very simple reason. See, if you take PS Member textbook, he has given clearly, according to Indian standards, there is no exact definition for transformation ratio K. Some textbooks they'll be taking N2 by N1, E2 by N1, E2 by E1. Some textbooks they'll be taking E1 by E2, N1 by N2. There is no exact definition for transformation ratio K. Are you getting what I'm saying? Excuse me.
Yes,
Hello?
sir.
There is no exact definition for transformation ratio K, ma. But why I'm asking you to remember, formula number 1 means, so if you see previous GATE questions, previous IES questions, previous PSC questions, so each and every questions will be getting answer if you remember from equation number, if you remember formula number 1. So I suggest you remember K formula, E2 by E1, N2 by N1, trans ratio means N1 by N2. Okay, please remember this formula number 1, not formula number 2. Is it clear, everybody?
Okay.
It doesn't mean that it is wrong. It doesn't mean that second one is wrong. Okay, second one is also correct. But maybe he is following, person who is setting the question paper, he is following this notation. Which notation? K equal to N2 by N1, E2 by E1, he is following that notation. So if you see, maximum questions can be solved by using formula number 1. Okay, guys, that's why I had given here K equal to E2 by E1, N2 by N1, and turns ratio N1 by N2. Okay, so please, why I'm writing this one clearly means, so in some examination GATE questions, no, they'll give question like this. Figure shows, transformer having turns ratio 2. Please try to understand clearly. Transformer having turns ratio 2, like that they'll give. Tell me turns ratio 2 means you will take that 2 as what, ma? N1 by N2 or N2 by N1? Are you getting my question?
N1 by N2.
Please, very good. Respond everybody. Transformer having turns ratio 2 means you will take that 2 value as N1 by N2 or N2 by N1?
N1 by N2, sir.
Because turns ratio are given formula, N1 by N2 has given, so indeed he has given N1 by N2 value. Suppose if you don't know definition for turns ratio and a transformation ratio, some questions cannot be solved. So please be careful. So turns ratio means primary turns by secondary turns, whereas transformation ratio means secondary turns by primary turns. That's it. Okay, guys. So you do one thing. I'll give you one question. So this is about EMF equation. And so tomorrow, guys, let me tell you what I'm just going to explain. Let me first of all give a small, for 1 minute I'll give some information so that I'll start tomorrow. I'm just going to explain angle between different vectors, like angle between supply voltage and I mu, angle between I mu and pi, angle between pi and E1, angle between pi and E2, angle between E1 and E2, angle between V1 and E1. Like this, I will explain angle between all vectors. Now, after explaining this one, no, I'll go for, in the meanwhile, I'll solve one previous GATE question. Next, I'll be explaining a equivalent circuit of transformer under no load condition, vector diagram of transformer under no load condition. Okay, and equivalent circuit of transformer in the meanwhile, I can solve some questions here once again. So, equivalent circuit of transformer under load condition and vector diagram of transformer under load condition. Okay, and after this, I'll explain features of transformers, features of ideal transformer, effect of winding resistance, on the operation of transformer topic I'll take. Because see, ideal transformer means, guys, tell me what is for ideal transformer, what is the primary winding resistance value? Can you please tell me? For ideal transformer, what might be the winding resistance value? Please, generally I'm asking you. For ideal transformer, what is the winding resistance value?
0, sir.
Very good, ma. Very good. So ideally 0 resistance, but practically some resistance will be there, will not be there.
Will be there.
Will be there. Though if you take a very good conductor also, will be have some resistance. That I will take. Okay, effect of winding resistance we'll discuss. Similarly, we'll discuss about leakage flux. I'll give a definition also what is leakage flux, all those things. And ideally we'll take leakage flux 0, but practical leakage flux will be there. Effect of leakage flux on the operation of transformer. That topic also I'll take. So after explaining these two topics, I'll explain exact equivalent circuit of transformer. Okay, after showing winding resistance, and I'll show something which is used to compensate leakage flux, that becomes exact equivalent circuit of transformer. Okay, so after completion of equivalent circuit of transformer, I'll be taking losses, efficiency, regulation, OC test, SC test. So in these areas, you'll be getting so many questions. If you see those people who are preparing for TNEB, TRB, and also, so you'll be getting more questions from this one, losses, efficiency, regulation. So coming videos are very important for GATE, for ESC, as well as for TNEB and TRB also. Okay, guys. So simply today's class, you can take it as a basic class. So okay, I already started we entered into subject also, but full-fledgedly we'll enter from tomorrow onwards. Okay, you promise me one thing, everybody. Okay, please, whatever the class I had taken, this 6 hours class, please sit for at least half an hour or 1 hour. Please try to please try to watch videos, or try to learn all those things, whatever, once again for half an hour. Then subject become very easy for you for tomorrow's class. Okay, guys. In the meanwhile, you please try this question. Are you able to see this question, guys? Everybody? Are you able to see this question, everybody on the board?
Yes, sir.
Please try to see this. Try to, like, if you want, I can write here once again. The low voltage winding. Let me erase this. You are not able to see here. Sorry. If you want, you can note down the low voltage winding of it's regarding EMF equation. To be frank, this syllabus is not completed, but I'm asking you to do. I think if you are able to do, very good. If you are not able to do, also very good, because tomorrow I'm just going to explain. So I'll tell you why I had given this question to you. It's regarding EMF equation. So please try once. If you are not getting also, don't mind, just try once. Low voltage winding of a 400 volts by 230 volts single phase 50 Hz transformer is to be connected to a 25 Hz. The supply voltage should be dash. And I promise you, from tomorrow onwards, more problematic questions will come. Today, I think we did not solve questions also. To be frank, we did not solve questions because I'm covering only theory and a concept. From tomorrow onwards, questions will come. Is it clear, guys? Everybody?
Yes, sir.
Okay, ma. And I'll give time 2 minutes. I think time is already complete. I can understand that. I'll give time for 2 minutes. Please ask whatever the doubts you are having. If you want me to open slide, I will open the slide and you can ask doubts, please. Please. Whatever the doubts you are having for today's class, you can ask those doubts, please. EMF equation or what I'm asking, problems, or no, static EMF, self, mutual, or this question, or once again. You please, if you have any doubts, you can ask me. Any doubts? Any doubts?
No,
I think doubts has to come. Yogeshwaran, Aarti, Gopinath, Harish, Nirmala, Rahul, Vignesh, Shubha, Vidyavani. Suppose I am damn sure that, guys, if you are able to sit for 6 hours for today's class, no, tomorrow definitely you will sit out. You will sit because no, it's a very theory topic today. You are capable of sitting continuously for 6 hours. From tomorrow onwards, no, you'll be having problems will come. Problematic will come. It's not a total theory. Theory was completed now. Maximum theory was completed. So maybe theory may come after 2 to 3 classes. But for tomorrow's class or for day after tomorrow's class, we'll be dealing with the problems. So you can have interest. You will be having some interest. So please, you can ask doubts, ma. Nirmala, Aarti, please respond.
No doubt, sir.
no doubt, sir.
Harish, Rahul, Vignesh.
Clear, sir.
I think maximum people will be having a doubt in this area. I hope. Which one? See, in this problem. I hope.
While solving, we will get, I think, sir. Now we are understanding.
I
while
think you are
solving.
having problem here. Okay, we'll be having problem here. Please don't confuse. Suppose try to find out polarity from your side, and please try to see the polarities what he has given, and try to apply formula minus n to d pi by dt. And suppose find out polarities and try to see whatever the polarity he has given. If he has given reverse polarities, please try to reverse the question, reverse the answer, whichever you got. That's it. So no problem. You please try once. If you are having doubt, you can ask it tomorrow. Okay, guys. Thank you, everybody. Thank you, everybody.
Thank you,
Sir?
sir.
Okay, guys, thank you.
Sir?
Thank you, ma.
Thank you, sir.
Tomorrow what time class, sir?
I think Sir told me tomorrow class will be from morning 7 to 9. I think so. It's not confirmed. You please try to confirm from your institute. Okay. I told
sir.
that. I think they told from morning 7 to 9. If I'm correct.
Okay, sir.
7 to 9. Okay. Right. Okay. Thank you.
Thank
very
you.
much.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you.
Thank you, sir.
Thank you, man.